The turning point underscores science, society, and Fritjof Capra. This study examines Fritjof Capra's The Turning Point, Science, Society, and a Rising Culture, 1982. The physicist system synthesis full-length diagnosis of the Cartesian-Newtonian mechanical worldview as the common root of our health, economic, energy, and spiritual crises, and his proposal of an ecological, systems-based new vision of reality as the cultural turn we are now passing through. The summary follows the book's own movement: crisis, the two paradigms, the Newtonian world machine, the new physics, the Cartesian inheritance across biology, medicine, psychology, and economics, the dark side of growth, and the new vision's four faces: systems biology, wholeness and health, journeys beyond space and time, and the passage to the solar age. In Capra's first-person register of a physicist describing a revolution from the inside. Abstract. This study examines Fritjof Capra's The Turning Point, Science, Society, and the Rising Culture, 1982, the physicist author of the Tao of Physics, enlarging his thesis into a full diagnosis of Western civilization. The book argues that the multifaceted crisis of our century, nuclear and environmental, economic, medical, and spiritual, is a crisis of perception rooted in the Cartesian-Newtonian mechanical worldview that has dominated our culture for 300 years. Part 1 sets the crisis in the context of cultural evolution, with a paradigm shift occurring in the twilight of Sorokin's sensate culture. Part 2 contrasts the two paradigms, the Newtonian world machine and the new physics, which reveals the universe as an interconnected, dynamic web in which the observer is essential. Part 3 traces the influence of Cartesian thought on biology, medicine, psychology, and economics, the reductionist paradigm failing before the integrative functions of living systems, the health crisis, the psychology without a soul, and the impasse of economics. Part 4 sets out the new vision of reality, the system's view of life, generative of a new concept of health as dynamic balance. The integration of Western psychotherapy with the transpersonal psychology of Jung, Wilber, and Groff, and the passage to the solar age, with soft technologies, deep ecology, and the rising culture of social movements. The examination closes with the book's own hope. Evolutionary changes of this magnitude cannot be prevented by short-term political activities, and the rising culture will eventually assume its leading role. Executive summary. The turning point is at hand. We have stockpiled tens of thousands of nuclear weapons, poison our air, water, and food, and let the economy become an obsession with undifferentiated growth that depletes the planet's resources. The experts can no longer solve the problems of their own fields. The book assembles these facets into a single pattern. They're all manifestations of one crisis, a crisis of perception, and the perception is that of the Cartesian-Newtonian worldview. The universe as a machine, the mind split from matter, nature as a resource to be dominated. The physicist's own revolution, which has shown the universe to be an interconnected, intrinsically dynamic web in which the observer's consciousness is essential, is the model. The other sciences, and the culture itself, must undergo the same shift to a holistic, ecological systems view. Central thesis. The central thesis is that the crisis of our time derives from the fact that we are applying the concepts of an outdated worldview, the mechanistic worldview of Cartesian-Newtonian science, to a reality that can no longer be understood in terms of those concepts. We live in a globally interconnected world in which biological, psychological, social, and environmental phenomena are all interdependent. To describe this world appropriately, we need an ecological perspective that the Cartesian worldview does not offer. What we need is a new paradigm, a fundamental change in our thoughts, perceptions, and values. The beginnings of this shift are already visible in all fields and the various social movements of the 60s and 70s. Ecology, anti-nuclear, feminist, human potential, holistic health, spiritual, are different aspects of the same new vision, which will flow together into a powerful force for social transformation, the rising culture. As a physicist, I can argue that a holistic framework is not only scientific, but is in agreement with the most advanced scientific theories of physical reality. Foundational observations. The crisis is systemic. Whether we talk about cancer, crime, pollution, inflation, or energy shortage, the dynamics underlying the problems are the same. They're facets of a single crisis that can be resolved only by changing the structure of the web of social and ecological relations. The Cartesian-Newtonian paradigm. The world as a perfect machine governed by exact mathematical laws, with the mind split from matter, reductionism as the method, and the domination of nature as the aim. The framework for 3 centuries of science and culture, now transcended by physics. The new physics. The universe as an interconnected, dynamic whole, probability waves, non-local connections, statistical causality, the observer's consciousness as essential, the bootstrap philosophy, without fundamental entities, the model for the other sciences. The reductionist failure. In biology, medicine, psychology, and economics, the mechanistic framework cannot grasp integrative functions and systemic problems. The diseases of civilization. The psychology without a soul, the impasse of economics. Health as dynamic balance. The system's view of health, flexibility, integration, the 3 levels of individual, social, and ecological health, stress as imbalance, illness as a message, and the holistic therapies consistent with it. The system's view of life, self-organization, self-renewal, self-transcendence, symbiosis, the Gaia hypothesis, evolution as creativity, spirituality as the deepest essence of the new biology. The rising culture, the movements of ecology, feminism, anti-nuclear, human potential, and holistic health, which will flock together and form a powerful force of social transformation. The passage to the solar age, soft technologies, the solar transition, deep ecology, the redefinition of human nature by feminist spirituality, the transformation as a planetary turning point. Significance and recommendation. The significance of the turning point is that it provides a coherent conceptual framework for the social movements of our time, allowing them to recognize the commonality of their aims and to flow together into a powerful force for social change. It synthesizes modern physics, the system's view of life, Eastern and Western medicine, Jungian and transpersonal psychology, and ecological economics into a single vision of reality, a paradigm that is scientific and spiritual at the same time, rooted in the harmony between the views of scientists and mystics. The book's recommendation is ultimately a warning. The transformation of the old becomes easy only when the old is discarded and the new is introduced, both measures according with the time. Evolutionary changes of this magnitude cannot be prevented by short-term political activities, and the rising culture will eventually assume its leading role, our strongest hope for the future. 1. The turning of the tide. The multifaceted crisis. At the beginning of the last 2 decades of our century, we find ourselves in a state of profound, worldwide crisis, complex, multidimensional, touching every aspect of our lives. Health and livelihood, the quality of our environment and social relationships, economy, technology, politics. It is a crisis of intellectual, moral, and spiritual dimensions, unprecedented in recorded history. For the first time, we have to face the very real threat of extinction of a human race and of all life on this planet. We have stockpiled tens of thousands of nuclear weapons, enough to destroy the world several times over, and the arms race continues. World military spending has passed $1 billion a day, and half of the world scientists work on weapons. The military-industrial complex has become an integral part of government, and the Pentagon tries to persuade us that more weapons will make the country safer. The opposite is true. First strike strategies have become central to American defense policy, and each new missile merely increases the likelihood of global destruction. Nuclear power is the same threat under another name. 25 years ago, world leaders decided to use atoms for peace and presented nuclear power as the reliable, clean, and cheap energy source of the future. Today, we are painfully aware that it is neither safe, nor clean, nor cheap. The radioactive elements released by reactors are the same as the fallout of atomic bombs. And plutonium, the most toxic of these poisons, is itself fissionable. It can be used to build atomic bombs. Thus, nuclear power and nuclear weapons are inextricably linked, being but different aspects of the same threat to humankind. Even discounting a nuclear catastrophe, the global ecosystem is seriously endangered. Our cities lie under blankets of choking, mustard-colored smog. Our water and food are contaminated by synthetic chemicals marketed at a rate of 1,000 new compounds a year. The deterioration of the environment is matched by the chronic and degenerative diseases of civilization. Heart disease, cancer, strokes, and by psychiatric disorders springing from a parallel deterioration of our social environment. Along with these social pathologies come economic anomalies that confound our economists and politicians. Rampant inflation, massive unemployment, a gross maldistribution of income and wealth. Faced with this triple threat, our politicians no longer know where to turn first. They and the media argue about priorities without realizing that these problems, like all the others, are but different facets of a single crisis. Whether we talk about cancer, crime, pollution, nuclear power, inflation, or energy shortage, the dynamics underlying these problems are the same. The central purpose of this book is to clarify these dynamics and to point to directions for change. It is a striking sign of our time that the experts can no longer deal with the urgent problems of their own fields. Economists cannot understand inflation. Oncologists are confused about cancer. Psychiatrists are mystified by schizophrenia. The intellectual elite that once formulated the mainstream academic view has split into dozens of rivulets. None of the retreating intellectuals identified the real problem. Most academics subscribe to narrow perceptions of reality, inadequate for dealing with the major problems of our time. These are systemic problems, closely interconnected and interdependent. They cannot be understood within the fragmented methodology of our academic disciplines and government agencies, which will never resolve our difficulties but merely shift them around in the complex web of social and ecological relations. A resolution can be found only if the structure of the web itself is changed. Transformation in the perspective of cultural evolution. To understand our multifaceted cultural crisis, we need a broad view. Our situation in the context of human cultural evolution, a perspective of thousands of years rather than decades, of dynamic patterns of change rather than static social structures. Seen from this perspective, crisis appears as an aspect of transformation. The Chinese, who have always had a dynamic worldview and a keen sense of history, seem to have been well aware of this connection. Their term for crisis, Weiji, is made of the characters for danger and opportunity. Western sociologists have confirmed the ancient intuition. Periods of cultural transformation are typically preceded by social indicators. Alienation, increased mental illness, violent crime, social disruption, a rise in religious cultism. Many identical to the symptoms of our current crisis, appearing 1 to 3 decades before the transformation and falling away after it. All civilizations seem to go through cyclical processes of genesis, growth, breakdown, and disintegration. In Toynbee's A Study of History, the genesis of a civilization is a transition from static condition to dynamic activity, a pattern he calls challenge and response. A challenge from the natural or social environment provokes a creative response that carries the society into the process of civilization. The essential element in cultural breakdown is a loss of flexibility. When social structures become so rigid that the society can no longer adapt, it breaks down and disintegrates. But even during disintegration, creative minorities appear on the scene and carry on the process of challenge and response. The dominant institutions refuse to hand over their leading roles, yet they inevitably decline, and the creative minorities transform some of the old elements into a new configuration. The recurrent rhythm in cultural growth relates to processes of fluctuation observed throughout the ages. The ancient Chinese believed that all manifestations of reality are generated by the dynamic interplay of two polar forces, yin and yang. Heraclitus compared the world order to an ever-living fire, kindling in measures and going out in measures. Pitirim Sorokin mapped the fluctuation of value systems in a monumental 4-volume work, distinguishing the sensate, matter alone is ultimate reality. The ideational, true reality lies in the spiritual realm, and the idealistic, the harmonious blending of the two. In his model, the current paradigm shift and the decline of the industrial age are another period of decline of sensate culture, which he predicted in 1937. Sorokin's analysis suggests very forcefully that our crisis is no ordinary crisis, but one of the great transition phases of human history. Mumford counts fewer than half a dozen in the entire history of Western civilization. The transformation we are experiencing now may well be more dramatic than any of the preceding ones. The decline of patriarchy, the end of the fossil fuel age, and the paradigm shift occurring in the twilight of the sensate culture are all contributing to the same global process. As individuals, as a society, and as a planetary ecosystem, we are reaching the turning point. Cultural transformations of this magnitude cannot be prevented. They should be welcomed as the only escape from agony, collapse, or mummification. What we need is a deep re-examination of the main premises and values of our culture, a rejection of the conceptual models that have outlived their usefulness, and a new recognition of values discarded in previous periods of our history. It will be crucial to go beyond attacking particular social groups or institutions and to show how their attitudes and behavior reflect an outdated value system that underlies our whole culture. Only then will we be able to approach the harmonious, peaceful transition described in the Chinese I Ching. The movement is natural, arising spontaneously. For this reason, the transformation of the old becomes easy. The old is discarded and the new is introduced. Both measures accord with the time. Therefore, no harm results. The major alternative to this model is the Marxist view of history known as dialectic materialism, which locates the roots of social evolution in economic and technological developments and asserts that all changes in society arise from the development of its internal contradictions, embodied in its classes. The Marxist view resembles ours in its rhythmic character, but differs in its emphasis on conflict and struggle. Class struggle was the driving force of history for Marx, much as struggle was for Darwin in biological evolution. I believe this view overemphasizes struggle, overlooking the fact that all struggle in nature takes place within a wider context of cooperation. Following the I Ching rather than the Marxist view, I believe conflict should be minimized in times of social transition. Yin, Yang, and the cultural imbalance. For our discussion of cultural values, we will use the framework of the I Ching, which lies at the basis of Chinese thought. The Chinese philosophers saw reality, whose ultimate essence they called Tao, as a process of continual flow and change. All developments in nature show cyclical patterns. The polar opposites Yin and Yang set the limits for the cycles of change. The Yang having reached its climax retreats in favor of the Yin having reached its climax retreats in favor of the Yang. These opposites are not different categories, but extreme poles of a single whole. Nothing is only Yin or only Yang. What is good is the balance between them. What is harmful is imbalance. The frequent Western association of Yin with passivity and Yang with activity reflects patriarchal stereotypes. Yin corresponds to responsive, cooperative activity, Yang to aggressive, expanding, competitive activity. These two kinds of activity are related to the two modes of consciousness recognized throughout the ages. Rational thinking is linear, focused, and analytic, and its knowledge tends to be fragmented. Intuitive knowledge arises from a direct, non-intellectual experience of reality and is synthesizing, holistic, and nonlinear. Looking at these opposites, it is easy to see that our society has consistently favored the Yang over the Yin, rational knowledge over intuitive wisdom, science over religion, competition over cooperation, exploitation over conservation. This emphasis, supported by the patriarchal system and encouraged by 3 centuries of sensate culture, has led to a profound cultural imbalance, which lies at the very root of our current crisis. In describing its manifestations, I shall pay particular attention to their effects on health, understood broadly as individual, social, and ecological health. According to Chinese wisdom, none of the values pursued by our culture is intrinsically bad, but by isolating them from their polar opposites and investing the Yang with moral virtue and political power, we have brought about the current sad state of affairs. Our culture takes pride in being scientific. Scientific knowledge is considered the only acceptable kind. This attitude, known as scientism, pervades all our institutions. When President Johnson needed advice about warfare in Vietnam, his administration turned to theoretical physicists, not specialists in electronic warfare, but the high priests of science. He might have been much better served by the poets, but that is unthinkable. The emphasis on rational thought is epitomized in Descartes' cogito, ergo sum I think, therefore I exist, which encouraged us to equate our identity with our rational mind rather than with our whole organism. Retreating into our minds, we have forgotten how to think with our bodies. The division between mind and matter led to a view of the universe as a mechanical system of separate objects reduced to fundamental building blocks. A view extended to living organisms regarded as machines, and has led to the fragmentation of our academic disciplines and to the exploitation of the natural environment as if it consisted of separate parts. Exploitation of nature has gone hand in hand with the exploitation of women, identified with nature throughout the ages. The ancient association of woman and nature is the source of a natural kinship between feminism and ecology. As Carolyn Merchant writes, the mechanical worldview sanctioned the domination of both nature and women. Overemphasis on rational, analytic thinking has led to attitudes that are profoundly anti-ecological. The understanding of ecosystems is hindered by the very nature of the rational mind. Rational thinking is linear, whereas ecological awareness arises from an intuition of nonlinear systems. One of the most difficult things for people in our culture to understand is that if you do something that is good, more of the same will not necessarily be better. This, to me, is the essence of ecological thinking. Ecosystems sustain themselves in a dynamic balance based on cycles and fluctuations, which are nonlinear processes. Linear enterprises, such as indefinite economic growth, will necessarily interfere with the natural balance and eventually cause severe damage. In our evolution, there has been an increasing separation between biological and cultural aspects of human nature. Biological evolution stopped some 50,000 years ago, and we have modified our environment so thoroughly that we have lost touch with our biological and ecological base more than any culture in the past. With a striking disparity between intellectual power and technological skills on the one hand, and wisdom, spirituality, and ethics on the other, our progress has been largely a rational and intellectual affair. And this one-sided evolution has reached a situation so paradoxical that it borders on insanity. The rising culture and the role of physics. The yin/yang terminology is especially useful in an analysis of cultural imbalance that adopts a broad ecological view, a view that could also be called a systems view in the sense of general systems theory, which looks at the world in terms of the interrelatedness and interdependence of all phenomena. An integrated whole whose properties cannot be reduced to those of its parts is called a system. Living organisms, societies, and ecosystems are all systems, forming multileveled structures of subsystems, holons, in Arthur Koestler's word, each balancing an integrative tendency to function as part of a larger whole against a self-assertive tendency to preserve its individual autonomy. Excessive self-assertion manifests itself as power, control, and domination. The patterns prevalent in our society, built into our centralized, standardizing technology and into the promotion of competition over cooperation rooted in the social Darwinist view that all life is a struggle for existence ruled by survival of the fittest. Our culture has consistently promoted and rewarded the yang and disregarded the yin, the feminine and intuitive aspects. Today, however, we are witnessing the beginning of a tremendous evolutionary movement. The turning point we are about to reach marks, among many other things, a reversal in the fluctuation between yin and yang. The yang, having reached its climax, retreats in favor of the yin. Our 60s and 70s have generated a whole series of movements that all seem to go in the same direction. The rising concern with ecology, with citizen movements pointing out the limits to growth and developing soft technologies. The anti-nuclear movement, fighting the most extreme outgrowth of our macho technology, the shift from material consumption to voluntary simplicity and inner growth, and, perhaps most important, the rise of feminist awareness in the women's movement. These movements form what Theodore Roszak has called the counterculture. So far, many of them still operate separately, but once they recognize the commonality of their aims, they will flow together into a force for social transformation. Following Toynbee's model of cultural dynamics, I shall call this force the rising culture. I shall argue that physicists can play an important role in this process. Since the 17th century, physics has been the shining example of an exact science and the model for all the others. Whenever psychologists, sociologists, or economists wanted to be scientific, they turned to the concepts of Newtonian physics. In the 20th century, however, physics has gone through conceptual revolutions that reveal the limitations of the mechanistic worldview and lead to an organic, ecological view which shows great similarities to the views of mystics of all ages. The universe no longer appears as a machine made of separate objects, but as a harmonious, indivisible whole. A network of dynamic relationships that include the human observer and his or her consciousness in an essential way. The fact that modern physics, an extreme specialization of the rational mind, is now making contact with mysticism, an extreme specialization of the intuitive mind, shows the complementary nature of the yang and the yin. In a culture dominated by science, it will be much easier to convince our institutions that fundamental changes are necessary if we can give them a scientific basis. This is what physicists can now provide. Physicists have learned that all concepts and theories are limited. As Heisenberg phrases it, every word or concept, clear as it may seem to be, has only a limited range of applicability. Scientists do not deal with truth. They deal with limited and approximate descriptions of reality. The following chapters will show how the sciences and humanities have modeled themselves after classical Newtonian physics. And now that physicists have gone beyond this model, it is time for the other sciences to expand their underlying philosophies. The systemic nature of the crisis, cancer, crime, pollution, inflation, and energy shortage are but different facets of a single crisis, resolvable only by changing the structure of the web of social and ecological relations itself. Weiji, the Chinese term for crisis, composed of the characters for danger and opportunity. Crisis as an aspect of transformation. Challenge and response. Toynbee's pattern of cultural genesis and growth, in which creative minorities rise to fresh challenges while the dominant institutions rigidly decline. Sensate, ideational, and idealistic value systems. Sorokin's three value systems whose cyclical waxing and waning traces the great cultural waves, the current paradigm shift being the twilight of the sensate era. The rising culture, the ecological, feminist, anti-nuclear, human potential, and holistic health movements, which will flow together into a powerful force of social transformation once they recognize the commonality of their aims. Quote, "The movement is natural, arising spontaneously. For this reason, the transformation of the old becomes easy. The old is discarded and the new is introduced. Both measures accord with the time. Therefore, no harm results." I Ching, as cited by Capra. Quote, "This, to me, is the essence of ecological thinking. Ecosystems sustain themselves in a dynamic balance based on cycles and fluctuations, which are nonlinear processes." Quote, "Scientists do not deal with truth. They deal with limited and approximate descriptions of reality." 2. The Newtonian world machine. The organic worldview and the scientific revolution. The worldview at the basis of our culture was formulated in the 16th and 17th centuries, when a dramatic shift in the way people pictured the world gave Western civilization the features characteristic of the modern era. Before 1500, the dominant worldview in Europe was organic. People lived in small, cohesive communities and experienced nature in terms of organic relationships, the interdependence of spiritual and material phenomena, the subordination of individual needs to the community. This framework rested on two authorities, Aristotle and the Church. Aquinas, combining Aristotle with Christian theology and ethics, and medieval science, based on both reason and faith, sought the meaning and significance of things rather than prediction and control. The medieval outlook changed radically in the 16th and 17th centuries. The notion of an organic, living, spiritual universe was replaced by that of the world as a machine, and the world machine became the dominant metaphor of the modern era. The development was brought about by revolutionary changes in physics and astronomy. Copernicus, Galileo, Newton, and by a new method of inquiry advocated forcefully by Francis Bacon, involving the mathematical description of nature and the analytic method of reasoning conceived by Descartes. The scientific revolution began with Nicholas Copernicus, who overthrew the geocentric view of Ptolemy and the Bible that had been accepted dogma for 1,000 years. The Earth became merely one of the planets circling a minor star at the edge of the galaxy. Aware that his view would offend the religious consciousness of his time, he delayed publication until the year of his death and presented the heliocentric view merely as a hypothesis. Johannes Kepler, a scientist and mystic, gave further support with his celebrated empirical laws of planetary motion. But the real change was brought about by Galileo Galilei, who directed the newly invented telescope to the skies, discredited the old cosmology beyond doubt, and established the Copernican hypothesis as a valid theory. Galileo's role goes far beyond astronomy. He was the first to combine scientific experimentation with mathematical language to formulate the laws of nature, and is considered the father of modern science. Philosophy, he believed, is written in that great book which ever lies before our eyes. But we cannot understand it if we do not first learn the language and characters in which it is written. This language is mathematics. To make this possible, Galileo restricted science to the measurable properties of bodies, shapes, numbers, movement, excluding color, sound, taste, smell as subjective projections. The strategy proved extremely successful, but exacted a heavy toll. As R.D. Lang put it, experience as such is cast out of the realm of scientific discourse, and with it aesthetics, ethical sensibility, values, quality, form. Hardly anything has changed our world more than this obsession with measurement. Francis Bacon set forth the empirical method explicitly in England, the first clear theory of the inductive procedure, making experiments and drawing general conclusions, tested in further experiments. The Baconian spirit profoundly changed the purpose of science, from the ancients' goal of wisdom, understanding, and living in harmony with the natural order, integrative purposes, to knowledge for dominating and controlling nature. Bacon's advocacy was not only passionate but vicious. Nature had to be hounded in her wanderings, bound in his service, made his slave. The scientist's aim was to torture nature's secrets from her. Much of this violent imagery seems inspired by the witch trials of his time, and his view of nature as a female whose secrets must be tortured from her with mechanical devices is strongly suggestive of the torture of women in the early 17th century, an outstanding example of patriarchal attitudes in science. Descartes, the view of nature as a perfect machine. René Descartes accepted no traditional knowledge, but set out to build a new system of thought. At 23, an illuminating vision showed him a method for constructing a complete science of nature about which he could have absolute certainty, based on self-evident first principles, and implanted a firm belief in the certainty of scientific knowledge. We reject all knowledge which is merely probable. Here Descartes went wrong. 20th century physics has shown that all our concepts and theories are limited and approximate. The Cartesian belief in scientific truth, reflected in the scientism typical of our culture, contributed to our current cultural imbalance. Cartesian certainty is mathematical in its essence. Descartes believed that the key to the universe was its mathematical structure. His desire to describe nature mathematically led to his most celebrated discovery, analytic geometry, correlating algebra and geometry, allowing a general mathematical analysis of moving bodies. My entire physics is nothing other than geometry. His method, presented in the Discourse on Method, rests on radical doubt. He doubts everything, tradition, the senses, even his body, until he reaches what he cannot doubt, himself as thinker. Hence cogito, ergo sum. The essence of human nature lies in thought. Certain knowledge is achieved through intuition and deduction. The method is analytic, breaking up thoughts and problems into pieces and arranging them in logical order. It is probably Descartes' greatest contribution to science. Its overemphasis has led to the fragmentation of our thinking and disciplines, and to reductionism, the belief that complex phenomena can be understood by reducing them to their constituent parts. The cogito made mind more certain than matter, and led Descartes to conclude the two were separate and fundamentally different. The division taught us to see ourselves as isolated egos inside our bodies, set mental above manual work, kept doctors from the psychological dimensions of illness and psychotherapists from their patients' bodies, and made quantum theory's founders struggle to interpret their observations. As Heisenberg wrote, the partition will take a long time to be replaced by a really different attitude toward the problem of reality. Descartes based his view of nature on this division between residential cogitans, the thinking thing, and residential extensa, the extended thing, both creations of God. Later scientists dropped the reference to God, the humanities concentrating on mind, the sciences on matter. To Descartes, the material universe was a machine and nothing but a machine. Nature worked by mechanical laws, everything explained by the arrangement and movement of its parts. This picture became the dominant paradigm of science, and the change in the image of nature had a strong effect on attitudes toward the environment. As Carolyn Merchant writes, the image of the earth as a living organism and nurturing mother served as a cultural constraint restricting the actions of human beings. Those constraints disappeared with the mechanization of science, which sanctioned the manipulation and exploitation of nature. Descartes shared Bacon's aim that knowledge be used to render ourselves the masters and possessors of nature. He extended mechanism to living organisms. Plants and animals were machines, the human body an animal machine, and, influenced by Baroque automata, declared, "I do not recognize any difference between the machines made by craftsmen and the various bodies that nature alone composes." This view shaped the life sciences for 3 centuries, but scientists, successful in treating organisms as machines, tend to believe they are nothing but machines. A reductionist fallacy most apparent in medicine, where the clockwork model has prevented understanding of many of today's major illnesses. Newton, the grand synthesis. The man who realized the Cartesian dream and completed the scientific revolution was Isaac Newton, born in 1642. The year of Galileo's death. A complete mathematical formulation of a mechanistic view, a grand synthesis of Copernicus, Kepler, Bacon, Galileo, and Descartes, remaining the solid foundation of science into the 20th century. He invented differential calculus to describe the motion of bodies, perhaps the greatest advance in thought that a single individual was ever privileged to make, said Einstein. Kepler had given empirical laws of planetary motion, Galileo the laws of falling bodies. Newton combined them in general laws governing all objects in the solar system. The insight, according to legend, coming with a falling apple, the same force pulling apple and moon. His Principia, a system of definitions, propositions, and proofs regarded as the correct description of nature for 200 years, set out his experimental method. Whatever is not deduced from the phenomena is to be called a hypothesis. Mixing Bacon's empirical method with Descartes' rational deduction, Newton developed the methodology on which natural science has been based ever since. Newton was far more complex than his scientific writings suggest. Also lawyer, historian, theologian, deeply involved in alchemy, apocalyptic texts, and esoteric knowledge, the last of the magicians. The stage of his universe was absolute Euclidean space, without regard to anything external, always similar and immovable, and absolute time, flowing uniformly without regard to anything external. Its elements were material particles, small, solid, indestructible, all made of the same homogeneous substance, their differences only in the density of packing. The force of gravity acted instantaneously at a distance, and both particles and force were created by God, not subject to further analysis. This image of atoms as hard building blocks made physics a hard science and fed the hard technology upon it. Only in the mid-20th century did it become clear that this too belonged to a paradigm that would be transcended. The Enlightenment, Physics as the model of all sciences. In the 18th century, physics naturally became the basis of all the sciences. If the world is a machine, ask mechanics how it works. All philosophy is like a tree, Descartes wrote. The roots are metaphysics, the trunk is physics, and the branches are all the other sciences. The thinkers of the Enlightenment applied mechanics to human nature and society, some even claiming a social physics. Its dominant figure was John Locke, who developed an atomistic view of society. As physics reduces gases to the motion of molecules, so Locke reduced the patterns of society to the behavior of individuals, built on the tabula rasa, the mind as a blank tablet imprinted by experience, an image that would shape behaviorism and psychoanalysis. Believing natural laws govern society as they do the universe, he held that government's function is to discover and enforce them. Freedom, equality, and the right to property as the fruit of one's labor. His ideals of individualism, free markets, and representative government underlie the Declaration of Independence and the American Constitution. The limits of the Newtonian model. Through the 19th century, the mechanistic model was elaborated in every science, but new discoveries made its limitations apparent. Electric and magnetic phenomena involved a new kind of force. Faraday and Maxwell, replacing the concept of force with that of the field, were the first to go beyond Newton, showing the fields had their own reality. Electrodynamics culminated in the realization that light is a rapidly alternating electromagnetic field traveling as waves. Maxwell himself still tried to explain his results mechanically, as states of stress in an all-pervasive ether. It remained for Einstein to declare that no ether existed, that the fields were entities in their own right, not mechanically explainable. Electromagnetism dethroned mechanics as ultimate theory. A new idea would dominate all future science, evolution. After the static great chain of being of antiquity, Lamarck proposed that living beings evolve from simpler forms under environmental pressure. Darwin established evolution beyond doubt with chance variation and natural selection. Evolution forced scientists to abandon the world machine that emerged fully built from the Creator's hands. But whereas biology saw evolution as movement toward increasing order, physics saw it as movement toward increasing disorder. The application of mechanics to heat led to thermodynamics. The first law, conservation of energy. The second law, the dissipation of energy, irreversible processes, and arrow of time. Any isolated system proceeds spontaneously toward increasing disorder. Rudolf Clausius named the measure of that direction entropy, and Ludwig Boltzmann explained it through probability. The second law is statistical. Certain processes merely extremely unlikely. In vast systems, entropy increases until heat death. All activity ceased. Classical physics has the universe running down to a halt, in sharp contrast to the biologist's living universe evolving toward greater complexity. Here is the deepest limitation of the Newtonian vision. A universe of billiard balls in random motion cannot deal with the evolution of life. By the end of the 19th century, Newtonian mechanics had lost its role as the fundamental theory, yet its basic ideas were still believed correct. The first 3 decades of the 20th century changed this radically. Relativity and quantum theory shattered the principal concepts of the Cartesian worldview: absolute space and time, elementary solid particles, fundamental material substance, strict causality, the objective description of nature, none of which could be extended to the new domains physics was entering. The world machine, the universe as a perfect mechanical system governed by exact mathematical laws, displacing the medieval organism. Galileo's quantification strategy, restricting science to the measurable properties of matter, excluding experience, quality, and value from scientific discourse. The Baconian spirit, science as knowledge for dominating and controlling nature. The reversal from yin, integrative purposes, to yang, self-assertive ones. The Cartesian division, the separation of mind, residential cogitans, and matter, residential extensa, isolating egos and bodies, and founding the split between humanities and sciences. Locke's atomistic society, Newtonian reductionism applied to society. The tabula rasa, the state of nature, the laws behind the American founding. Statistical mechanics and entropy, the limits of mechanism, the arrow of time, evolution toward disorder against the evolution of life toward complexity. Quote, out goes sight, sound, taste, touch, and smell, and along with them has since gone aesthetics and ethical sensibility, values, quality, form, all feelings, motives, intentions, soul, consciousness, spirit. Experience, as such, is cast out of the realm of scientific discourse. R.D. Lang, as quoted by Capra, quote, the image of the earth as a living organism and nurturing mother served as a cultural constraint restricting the actions of human beings. One does not readily slay a mother, dig into her entrails for gold, or mutilate her body. Carolyn Merchant, as quoted by Capra, quote, I do not recognize any difference between the machines made by craftsmen and the various bodies that nature alone composes. Descartes, as quoted by Capra. 3. The new physics. The two revolutions. At the beginning of modern physics stands the intellectual feat of one man, Albert Einstein. In 2 articles of 1905, he initiated 2 revolutionary trends: the special theory of relativity and a new way of looking at electromagnetic radiation, which would become characteristic of quantum theory, the theory of atomic phenomena. The complete quantum theory was worked out 20 years later by a whole team of physicists. Relativity was constructed almost entirely by Einstein himself. The special theory unified electrodynamics and mechanics, but radically changed the concepts of space and time, undermining a foundation of the Newtonian worldview. 10 years later, the general theory extended the framework to include gravity. The other development came from the experimental investigation of atoms. X-rays and radioactivity, inexplicable in classical terms, became tools for probing matter, and the exploration brought scientists into contact with a strange reality that shattered their worldview. Earlier revolutions, Copernicus, Darwin, had shocked the public, but their concepts were easy to grasp. Now physicists faced, for the first time, a challenge to their ability to understand the universe. Every question put to nature in an atomic experiment was answered with a paradox. The problem was not only intellectual, but an intense emotional crisis. Heisenberg recalled discussions with Bohr that went through many hours till very late at night and ended almost in despair. It took a long time to accept that the paradoxes arise whenever atomic phenomena are described in classical concepts. Gradually, the physicists learned to ask the right questions and finally found a precise and consistent mathematical formulation. Quantum theory was developed during the first 3 decades of the century by an international group: Planck, Einstein, Bohr, de Broglie, Schrödinger, Pauli, Heisenberg, Dirac. Even after its formulation was completed, its effect on their view of reality was shattering. The foundations of physics have started moving, wrote Heisenberg, and this motion has caused the feeling that the ground would be cut from science. Einstein described the same shock. It was as if the ground had been pulled out from under one. The oneness of a universe. 2 recurrent themes characterize the worldview emerging from modern physics: the universe as an interconnected web of relations, and the intrinsically dynamic nature of that web. The first arises in quantum theory. The exploration of the subatomic world revealed the dual aspect of matter. Light and its constituents behave sometimes as waves, sometimes as particles. The resolution of the particle/wave paradox forced physicists to question the concept of matter. At the subatomic level, matter shows tendencies to exist rather than existing at definite places. Atomic events show tendencies to occur. In the formalism of quantum mechanics, these tendencies are expressed as probabilities associated with wave-like quantities, probability waves. We can never predict an atomic event with certainty, only its likelihood. This has demolished the classical notion of solid objects. The solid objects of classical physics dissolve into wave-like patterns of probabilities, and these patterns do not represent probabilities of things, but probabilities of interconnections. The particles have no meaning as isolated entities, but can be understood only as correlations between various processes of observation and measurement. As Niels Bohr wrote, isolated material particles are abstractions, their properties being definable and observable only through their interaction with other systems. Particles are not things, but interconnections between things. In quantum theory, you never end up with things. This is how modern physics reveals the basic oneness of the universe. As we penetrate into matter, nature appears as a web of relations between the parts of a unified whole. As Heisenberg put it, the world thus appears as a complicated tissue of events. At the level of particles, the notion of separate parts breaks down. An elementary particle, in Stapp's words, is not an independently existing, unanalyzable entity. It is in essence a set of relationships that reach outward to other things. Gregory Bateson concluded that relationships should be the basis of all definitions, anything defined by its relations to other things. This shift from objects to relationships is closely related to the fundamental role of probability. In classical physics, probability is used when mechanical details are unknown, local variables residing within the objects involved. In atomic physics, beyond these local connections, there are non-local connections that are instantaneous and cannot be predicted precisely. These are the essence of quantum reality. Each event is influenced by the whole universe, an order expressible in statistical laws. In the macroscopic world, non-local connections are unimportant, and we speak of separate objects with certainty. At smaller dimensions, their influence grows, and it becomes increasingly difficult to separate a part of the universe from a whole. Einstein could never accept the existence of non-local connections. This was the subject of his debate with Bohr in the 1920s, conducted in the metaphor, God does not play dice. He admitted quantum theory was consistent, but remained convinced a deterministic interpretation in terms of local hidden variables would be found. A most fascinating episode, showing his philosophy to have been essentially Cartesian. Einstein devised the Einstein-Podolsky-Rosen (EPR) thought experiment. Two electrons, spinning in opposite directions, drift apart to a macroscopic distance. Quantum theory holds their spins about any axis to be correlated, even before measurement. And the observer, free to choose the axis at the last minute, instantly fixes the spin of the distant particle. No conventional signal could reach it. Einstein insisted this was impossible. Bohr held the two-particle system an indivisible whole, linked by non-local connections. 3 decades later, John Bell proved the question decisive. Bell's theorem shows local hidden variables are inconsistent with quantum mechanics, ruling out Einstein's Cartesian view. As Stapp sums it up, the theorem of Bell proves, in effect, the profound truth that the world is either fundamentally lawless or fundamentally inseparable. Statistical causality and the observer. The fundamental role of non-local connections and probability implies a new notion of causality. Classical science analyzed the world into parts arranged according to causal laws, a deterministic picture related to the image of nature as a clockwork. In atomic physics, this is no longer possible. The notion of separate parts is an idealization of only approximate validity. Individual events do not always have a well-defined cause. The jump of an electron from one orbit to another may occur spontaneously. This does not mean events occur arbitrarily. It means they are not brought about by local causes. The behavior of any part is determined by its non-local connections to the whole, so we replace the narrow classical notion of cause and effect by the wider concept of statistical causality. The probabilities for atomic events are determined by the dynamics of the whole system. In classical mechanics, the parts determine the whole. In quantum mechanics, the whole determines the parts. The structure of matter is not mechanical. James Jeans anticipated the point. Today, there is a wide measure of agreement that the stream of knowledge is heading towards a non-mechanical reality. The universe begins to look more like a great thought than like a great machine. The similarities between matter and mind should not surprise us. Human consciousness plays a crucial role in observation, determining to a large extent the properties observed. The observer is necessary not only to observe properties, but to bring them about. If I ask an electron a particle question, it gives a particle answer. If I ask a wave question, it gives a wave answer. The electron has no objective properties independent of my mind. The Cartesian division between observer and observed cannot be maintained. We can never speak about nature without speaking about ourselves. Modern physics has thus invalidated the ideal of an objective description of nature and challenged the myth of a value-free science. Scientists are responsible for their research not only intellectually but morally. In physics, the results have opened two very different paths, to the Buddha or to the bomb. The dynamic universe and relativity. The second major theme is that the cosmic web is intrinsically dynamic. The dynamic aspect of matter arises in quantum theory as a consequence of the wave nature of particles and is even more central in relativity, which shows that the being of matter cannot be separated from its activity. The probability patterns imply a fundamental restlessness of matter. A confined particle reacts by moving around. The smaller the confinement, the faster it jiggles. Macroscopically, objects seem inert, but a dead piece of stone is full of activity. There are no static structures, only stability of dynamic balance. Relativity forced us to abandon absolute space as the stage of phenomena and absolute time as a separate dimension. Both are relative concepts, elements of the language a particular observer uses to describe nature. Time is incorporated with the three space coordinates as a fourth coordinate, forming the inseparable four-dimensional continuum of space-time. We have no direct sensory experience of this, and whenever relativistic reality manifests itself in high velocities, we find it hard to deal with at the level of intuition and ordinary language. In quantum electrodynamics, antiparticles may be interpreted as particles moving backward in time. Particle interactions can stretch in any direction of space-time, and there is no before and after in the processes pictured by space-time diagrams. No linear relation of cause and effect, only interconnections. Relativity taught the same lesson as quantum mechanics. Our common notions are limited to our ordinary experience and must be abandoned when we extend it. The most important consequence of relativity was the realization that mass is a form of energy, E equals mc squared. Mass can be transformed into other forms of energy, as in high-energy collisions where particles are created and destroyed. Mass is no longer associated with a material substance. Particles are bundles of energy, energy being associated with activity. Particles can no longer be pictured as billiard balls, but as four-dimensional entities in space-time, dynamic patterns with a space aspect, appearing as objects with mass and a time aspect, involving their energy. The being and activity of matter cannot be separated. Even the forces between particles are pictured as the exchange of particles, unifying force and matter. Both have their common origin in the dynamic patterns we call particles. At the atomic level, the notion of substance no longer makes sense. What we observe are dynamic patterns continually changing into one another, the continuous dance of energy. The bootstrap approach and the implicate order. Current research aims at unifying quantum mechanics and relativity in a complete theory of particles. We have partial theories, quantum field theories for electromagnetic and weak interactions, and S-matrix theory, successful for strong interactions. Its philosophical foundation is the bootstrap approach, proposed by Geoffrey Chew in the early 1960s. Nature cannot be reduced to fundamental entities, but must be understood entirely through self-consistency. All of physics follows from the requirement that its components be consistent with one another. The bootstrap accepts no fundamental constants, laws, or equations. The universe is a dynamic web of interrelated events, the properties of each part following from the others. In my opinion, this raises physics to the level of Buddhist or Taoist philosophy, yet is pursued by only a small minority of physicists. Carried through, the approach would mean the basic structures of the material world are determined by the way we look at it, that observed patterns of matter are reflections of patterns of mind. The key element is the notion of order in the interconnectedness of subatomic processes classified by topology. Only a few categories of ordered relationships are consistent with the framework, precisely those observed in nature. The picture can be summed up in the phrase, every particle consists of all other particles, interrelated energy patterns that involve one another. David Bohm's theory of the implicate order comes even closer to dealing with consciousness explicitly. Starting from a notion of unbroken wholeness, Bohm explores an order enfolded at a deeper, non-manifest level, described by the analogy of a hologram, in which each part contains the whole. Since the hologram is too static, he coined the term holomovement for the dynamic reality from which all forms flow, regarding consciousness as an essential feature of it. Mind and matter are interdependent and correlated, not causally connected, mutually enfolding projections of a higher reality, which is neither matter nor consciousness. His theory and Schu's share the view of the world as a dynamic web, the central role of order, matrices for transformation, topology for categories, and the recognition that consciousness may be an essential aspect of the universe. A future theory may well arise from their merging. The worldview of modern physics. My presentation has been influenced by my personal beliefs. I have emphasized concepts not accepted by the majority of physicists, but significant philosophically and for our culture. Every contemporary physicist, however, will accept the main theme. Modern physics has transcended the mechanistic Cartesian view and is leading to a holistic and intrinsically dynamic conception of a universe. A systems view, consistent with the systems approaches emerging in other fields, where different but mutually consistent concepts describe different levels of reality without reducing one to another. In transcending the machine metaphor, we abandon the idea of physics as the basis of all science. The new vision is of a world in which the whole determines the parts. Order and consciousness are central, and the machine is transcended. There is motion but no moving objects, activity but no actors, no dancers, only the dance. Probability waves, the tendencies to exist of subatomic particles. Matter dissolves into wave-like patterns of probabilities. Non-local connections, instantaneous links between spatially separated events, the essence of quantum reality, proven by Bell's theorem against Einstein's Cartesian realism. Statistical causality, the whole determines the behavior of the parts. Individual atomic events have no local cause. The observer's consciousness, the participant observer brings about the properties he observes. The Cartesian division cannot be maintained. The bootstrap approach, nature understood through self-consistency alone, with no fundamental entities. Every particle consists of all other particles. The implicate order, Bohm's unbroken wholeness, the whole enfolded in each part, consciousness an essential feature. Quote, the theorem of Bell proves, in effect, the profound truth of the world is either fundamentally lawless or fundamentally inseparable. Henry Stapp, as quoted by Capra, quote, today there is a wide measure of agreement that the stream of knowledge is heading towards a non-mechanical reality. The universe begins to look more like a great thought than like a great machine. James Jeans, as quoted by Capra, quote, there is motion, but there are ultimately no moving objects. There is activity, but there are no actors. There are no dancers, there's only the dance. 4. The mechanistic view of life. The reductionist paradigm in biology. While the new physics was developing in the 20th century, the mechanistic Cartesian worldview maintained its strong influence on Western scientific thinking, and even today many scientists still hold to the mechanistic paradigm, although physicists themselves have gone beyond it. The new conception of the universe emerging from modern physics does not mean that Newtonian physics is wrong, or that quantum theory is right. Modern science has come to realize that all scientific theories are approximations to the true nature of reality, each valid for a certain range of phenomena. Beyond that range, new theories must be found to extend the old ones by improving the approximation. None can represent a complete and final account of nature. As Pasteur put it, science advances through tentative answers to a series of more and more subtle questions. The question, then, is where the limits of the Cartesian worldview lie in each field. In physics, the mechanistic paradigm had to be abandoned at the level of the very small in atomic and subatomic physics, and of the very large in astrophysics and cosmology. In other fields, the limitations may be of different kinds. In biology, the Cartesian view of living organisms as machines constructed from separate parts still provides the dominant conceptual framework. The belief that all aspects of living organisms can be understood by reducing them to their smallest constituents lies at the very basis of contemporary biological thinking. The passage from a current textbook expresses the reductionist credo. One of the acid tests of understanding an object is the ability to put it together from its component parts. Although the reductionist approach has been extremely successful, culminating in the unraveling of the genetic code, it has severe limitations. As the biologist Paul Weiss has observed, putting the pieces together again can yield no complete explanation of the behavior of even the most elementary living system. This is what most contemporary biologists find hard to admit. Carried away by the success of the reductionist method, they have organized biological research accordingly. Students are not encouraged to develop integrative concepts. Funds go almost exclusively to problems formulated within the Cartesian framework, and phenomena that resist reductionist explanation are deemed unworthy of investigation. As René Dubos has pointed out, biologists feel most at ease when the thing they're studying is no longer living. The problems today's biologists cannot solve, apparently because of this narrow approach, all concern the function of living systems as wholes and their interactions with their environment. The integrative action of the nervous system remains a profound mystery. We know many nervous circuits, but not how we breathe, regulate our temperature, digest, or focus our attention. Wound healing and pain remain largely mysterious. An extreme case is embryogenesis, the formation and development of the embryo, a process far too complex to lend itself to reductionist analysis and consequently considered a highly interesting but quite unrewarding topic. How will the situation change? I believe the change will come through medicine. The functions that resist reductionist description, the organism's integrative activities and its interactions with the environment, are precisely the functions crucial for health. Because Western medicine adopted the reductionist approach of modern biology and neglected to treat the patient as a whole person, physicians now find themselves unable to cure many of today's major illnesses, and there is growing pressure on them to develop a broader, holistic approach to health. Transcending the Cartesian model will amount to a major revolution in medical science, and since medicine and biology have been intimately associated since antiquity, Hippocrates and Galen, the Arab physician philosophers Linnaeus, Pasteur, Bernard, and Darwin all advanced biology. The two will likely be revolutionized together. The history of the Cartesian model in biology. Descartes created an uncompromising image of living organisms as mechanical systems, but left it to his followers to work out the details. The first success came when Giovanni Borelli explained aspects of muscle action mechanically, and the great triumph of the century when William Harvey applied the model to blood circulation, solving the most fundamental problem of physiology since ancient times. His treatise on the movement of the heart represents the crowning achievement of mechanistic physiology. But attempts to apply the method to digestion and metabolism were dismal failures. The phenomena involved chemical and electrical processes unknown at the time. A rival school, rooted in the alchemical tradition of Paracelsus, held that life was a chemical process and disease an imbalance of body chemistry. The two camps became the iatrochemists and the iatromechanists, with the mechanists in the majority. 18th century chemistry. Lavoisier showing respiration to be a form of oxidation. Galvani demonstrating the electric current of nerve impulses, raised physiology to a new level. The simplistic mechanical models were abandoned, but the essence of the Cartesian idea survived. Animals were still machines, only far more complicated than clockworks. The strict version found its most forceful expression in La Mettrie's polemical Man and Machine, which denied any essential difference between humans and animals. The human body is a clock, but immense and constructed with such ingenuity and skill. Joseph Needham, defending La Mettrie in 1928, declared that mechanism and materialism lie at the foundation of scientific thought, concluding, in science man is a machine, or if he is not, then he is nothing at all. Later, as the historian of Chinese science, Needham became an advocate of the organismic worldview. His claim that biology may someday be described in terms of physics and chemistry need not be denied, but this does not mean these laws will be based on the view of organisms as machines. To understand the essence of living systems, scientists will have to abandon the reductionist belief that complex organisms can be described completely in terms of their constituents. The 19th century brought the formulation of cell theory, the beginning of modern embryology, the rise of microbiology, and the discovery of the laws of heredity. The recognition that all animals and plants are composed of cells gave the Cartesian paradigm a new meaning. Biological functions were no longer seen as reflecting the organization of the organism as a whole, but as the results of interactions between the cellular building blocks. The cell itself was compared to a factory, yet cell biology, though enormously successful in describing the cell subunits, remained ignorant of the coordinating activities that integrate them. And unlike a factory's machinery, the cell's equipment is periodically disassembled and rebuilt in harmony with the overall dynamics of its functioning. Cells are organisms in their own right, and their integrative activities cannot be understood within the reductionist framework. The perfected microscope then generated microbiology, dominated by Pasteur, who settled the question of spontaneous generation, established the role of bacteria in fermentation, and demonstrated the correlation between germs and disease, a discovery whose simplistic interpretation made researchers treat bacteria as the only cause of disease, obsessed with the illusory goal of magic bullets. It eclipsed the subtler theory of Claude Bernard, the founder of modern physiology, who insisted on the intimate relation between organism and environment and formulated the concept of the milieu intérieur, the internal environment whose constancy is the essential condition of independent life. His emphasis on internal balance, rediscovered only in the 20th century, led to the notion of homeostasis. Genetics and molecular biology. Evolution, biology's major contribution to the history of ideas, forced scientists to replace the machine that emerged fully constructed from the creator's hands with the concept of an evolving system. But it did not lead biologists to modify the reductionist paradigm. On the contrary, they concentrated on fitting the Darwinian theory into the Cartesian framework, and were extremely successful in explaining the mechanisms of heredity. Lamarck had first proposed that animals change under environmental pressure and pass on those changes. His mechanism was wrong, but his recognition of evolution was revolutionary. Darwin established evolution beyond doubt with chance variation and natural selection, though his theory had a serious flaw. Because heredity was assumed to blend the parents' characteristics, a useful variation would be diluted away within a few generations. The solution, discovered by Gregor Mendel and ignored until the turn of the century, was that units of heredity, later called genes, do not blend, but are transmitted unchanged, so that random mutations would be preserved to be either reinforced or eliminated by natural selection. William Bateson named the new field genetics. In the 20th century, genetics became the most active area of biological research and reinforced the Cartesian approach. Geneticists believed they had pinned down the atoms of heredity, arranged linearly along the chromosomes, each gene corresponding to a trait, until research showed that a single gene affects a wide range of traits, and many genes combine to produce a single trait. The fallacy of genetic determinism, the belief that character traits are uniquely determined by the genetic makeup, is a direct consequence of regarding organisms as machines controlled by linear chains of cause and effect, ignoring that the organism is a multi-leveled system of mutually interacting levels. The same argument applies to evolution. The Darwinian concepts of chance variation and natural selection are only two aspects of a phenomenon better understood within a holistic framework, subtler and more useful than the dogmatic neo-Darwinian position expressed by Jacques Monod. Pure chance, absolutely free but blind, at the very root of the stupendous edifice of evolution. Genetic determinism has more recently given rise to sociobiology, which critics have shown not only unsound but dangerous. It encourages pseudoscientific justifications of racism and sexism by interpreting differences in human behavior as genetically pre-programmed and unchangeable. The belief that all properties of living organisms would eventually be explained in chemical and physical terms was expressed most clearly by Jacques Loeb's mechanistic conception of life. Living organisms are chemical machines. An unfortunate consequence of viewing living things as machines was the excessive use of vivisection. Descartes defended it, asserting that animals' cries meant no more than the creaking of a wheel. In the 20th century, the focus of biological research shifted from cells to molecules, culminating in the elucidation of the structure of DNA, among the greatest achievements of 20th century science, a triumph that led biologists to believe all biological functions can be explained in terms of molecular mechanisms, considerably distorting research in the life sciences. The breaking of the genetic code involved physicists moving into biology. Bohr's speculations about complementarity, elaborated by Delbruck, led Schrödinger to write What is Life, which treated the gene as a concrete physical substance, an information carrier, a hereditary code script, and convinced physicists, biochemists, and geneticists that a new frontier had opened. Pauling determined the structure of the protein molecule. Watson and Crick, using the X-ray data of Rosalind Franklin and Maurice Wilkins, determined the double helix structure of DNA. A gene is that length of the DNA double helix which specifies the structure of a particular enzyme. The 4 nucleotides, in their aperiodic sequence along the chain, embody the genetic information. The 2 chains separate in chromosome division, each serving as a template for a new complementary chain, and mutation is a chance error in this duplication. Biologists had discovered the alphabet of a universal language of life. But molecular biology has now become an exclusive way of thinking that has severely distorted biological research. Funds go to fashionable topics, important theoretical problems are ignored. As Sidney Brenner noted, nobody publishes theory in biology. Instead, they get out the structure of still another protein. Reductionism, the reigning credo of biology, complex phenomena understood by reducing them to their smallest constituents, from cells to genes to molecules. The reductionist fallacy, treating the dissection of organisms into parts as the whole of understanding. Integrative activities of the whole system escape it. The iatrochemists and iatromechanists, the 17th century camps, chemical versus mechanical explanations of life. The mechanists won, but the chemical view survived and triumphed in biochemistry. Genetic determinism, the belief that traits are uniquely determined by genes, a machine view of organisms, ignoring their multileveled interactions and the root of sociobiology. The century of molecular biology, from cells to molecules, culminating in the double helix and the universal language of life, the last and most distorting triumph of reductionism. Quote, "One of the acid tests of understanding an object is the ability to put it together from its component parts." From a contemporary biology textbook, as quoted by Capra, quote, "In science, man is a machine, or if he is not, then he is nothing at all." Joseph Needham, as quoted by Capra, quote, "Pure chance, absolutely free but blind, at the very root of the stupendous edifice of evolution." Jacques Monod, as quoted by Capra. 5. The biomedical model. The biomedical model and the exclusion of healing. Throughout the history of Western science, the development of biology has gone hand in hand with that of medicine. Naturally, the mechanistic view of life, once firmly established in biology, has also dominated the attitudes of physicians toward health and illness. The influence of the Cartesian paradigm on medical thought resulted in the biomedical model, which constitutes the conceptual foundation of modern scientific medicine. The human body is regarded as a machine that can be analyzed in terms of its parts. Disease is seen as the malfunctioning of biological mechanisms studied from the point of view of cellular and molecular biology, and the doctor's role is to intervene, physically or chemically, to correct the malfunctioning of a specific mechanism. 3 centuries after Descartes, as George Engel writes, medicine is still based on the notion of the body as a machine, of disease as the consequence of breakdown of the machine, and of the doctor's task as repair of the machine. By concentrating on smaller and smaller fragments of the body, modern medicine often loses sight of the patient as a human being and by reducing health to mechanical functioning, it is no longer able to deal with the phenomenon of healing, perhaps its most serious shortcoming. Although every practicing physician knows that healing is an essential aspect of all medicine, the phenomenon is considered outside the scientific framework. The term healer is viewed with suspicion, and the concepts of health and healing are generally not discussed in medical schools. The reason is evident. Healing cannot be understood in reductionist terms. It generally involves a complex interplay among the physical, psychological, social, and environmental aspects of the human condition. The concept of health, like the concept of life, cannot be defined precisely. What is meant by health depends on one's view of the living organism and its relation to the environment, and it changes from culture to culture and era to era. The broad concept needed for our cultural transformation, including individual, social, and ecological dimensions, will require a systems view of living organisms and, correspondingly, a systems view of health. The World Health Organization's definition is useful as a beginning. Health is a state of complete physical, mental, and social well-being, and not merely the absence of disease or infirmity. Although somewhat unrealistic, picturing health as a static state rather than a continually evolving process, it conveys the holistic nature of health that must be grasped to understand healing. Through the ages, healing has been practiced by folk healers who see illness as a disorder of the whole person, body, mind, self-image, dependence on the physical and social environment, relation to the cosmos. They never restrict themselves to purely physical phenomena. Through rituals and ceremonies, they attempt to influence the patient's mind, relieving the apprehension that is always a component of illness and stimulating the natural healing powers that all living organisms possess. In modern scientific terms, the healing process is the coordinated response of the integrated organism to stressful environmental influences. Biomedical researchers tend to disregard these practices. Such medical scientism makes them forget that the art of healing is an essential aspect of all medicine, and that scientific medicine itself had to rely on it almost exclusively until a few decades ago. The pluralism of medicine and the Cartesian Revolution. Western medicine emerged from a large reservoir of folk healing and spread over the world, retaining its basic biomedical approach. Writers now call it cosmopolitan medicine. But it is only one among many medical systems. Most societies show a pluralism of medical beliefs, with no sharp dividing line between systems. In addition to cosmopolitan medicine and folk healing, many cultures developed high tradition medicine. Indian, Chinese, Persian, based on written tradition, practiced by a professional elite, and holistic in theory, if not always in practice. The practice of popular medicine has traditionally been the prerogative of women, since the art of family healing is associated with motherhood. Folk healers derive their authority from their healing powers rather than from licensing. With the appearance of organized, high-tradition medicine, patriarchal patterns assert themselves and medicine becomes male-dominated. The grasp of power by a male professional elite accompanied the emergence of the rational, scientific approach to health. Its outcome was not only an almost exclusively male elite, but also the intrusion of medicine into domains like childbirth, traditionally the province of women, a trend now being reversed by the women's movement, which has recognized the patriarchal aspects of medicine as one more manifestation of the control of women's bodies by men. The greatest change in the history of Western medicine came with the Cartesian Revolution. Before Descartes, most healers addressed the interplay of body and soul, treating their patients within the context of their social and spiritual environment. Their approaches were usually concerned with the whole patient. Descartes' strict division between mind and body led physicians to concentrate on the body machine and neglect the psychological, social, and environmental aspects of illness. Interestingly, Descartes himself considered the union of body and soul essential to human nature. In his correspondence with Princess Elizabeth of Bohemia, whose physician he was, he diagnosed her affliction as largely due to emotional stress and prescribed relaxation and meditation in addition to physical remedies, showing himself far less Cartesian than most of today's medical profession. In the 17th century, William Harvey explained blood circulation in purely mechanistic terms. but other attempts to build mechanistic models failed. By the end of the century, it was apparent that a straightforward application of the Cartesian approach would not lead to further medical progress, and counter-movements emerged, among which homeopathy became the most successful. The germ theory and specific etiology. The rise of modern scientific medicine began in the 19th century with the great advances in biology. The reductionist trend proceeded in two directions. Rudolf Virchow postulated that all illness involved structural changes at the cellular level, establishing cellular biology as the basis of medical science. And Louis Pasteur began the intensive study of microorganisms. Pasteur's demonstration of a correlation between bacteria and disease had a decisive impact. Throughout medical history, physicians had debated whether a specific disease was caused by a single factor or by a constellation acting simultaneously. In the 19th century, these views were emphasized by Pasteur and Claude Bernard, respectively. Bernard concentrated on environmental factors, external and internal, and stressed illness as a loss of internal balance. Pasteur associated specific diseases with specific microbes. Pasteur and his followers won the debate triumphantly. And the germ theory, the doctrine that specific diseases are caused by specific microbes, was swiftly accepted, formulated precisely by Robert Koch in his postulates. The reasons for such complete acceptance were varied. Pasteur's genius and his flair for dramatic demonstration, the epidemics of the time, and above all the fact that the doctrine of specific disease causation fitted perfectly into the framework of 19th century biology. The identification of microbes with diseases provided a taxonomy of diseases, and the idea of a single cause was in perfect agreement with the Cartesian view of organisms as machines whose breakdown can be traced to the malfunctioning of a single mechanism. Physicians overlooked that Pasteur's own views were far subtler than the simplistic interpretation of his followers. As René Dubos has shown, Pasteur's view of life was fundamentally ecological. He was intensely interested in the terrain, the internal and external environment of the organism, recognizing that disease resulted from a complex interaction among host, germs, and environment. He took for granted that the healthy body resists many microbes and suggested that successful therapy depends on restoring the conditions favorable to natural resistance, even anticipating that mental states affect resistance to infection. The founder of microbiology had a view of illness broad enough to anticipate mind-body approaches to therapy that are still suspect to the medical establishment. But the doctrine of specific etiology shifted the focus of research from host and environment to microorganisms, and the resulting narrow view of illness is a serious flaw of modern medicine. On the other hand, the knowledge that microbes could infect surgical wounds revolutionized surgery. The antiseptic and then the aseptic method, together with anesthesia, put surgery on an entirely new basis. Advances in biology were accompanied by the rise of medical technology. The stethoscope, blood pressure instruments. Attention shifted from the patient to the disease. Pathologies were located and labeled. Hospitals were transformed from medieval houses of mercy into centers of diagnosis, therapy, and teaching, and the trend towards specialization began. The same emphasis was applied to mental disorders, for which the word psychiatry was coined. Rather than understanding the psychological dimensions of mental illness, psychiatrists sought organic causes, establishing psychiatry as a branch of medicine committed to the biomedical model, a problematic development that nonetheless inspired the psychological approach of Freud. The triumphs and the health crisis. 20th century medicine is characterized by the progression of biology to the molecular level, which became the scientific basis of medicine. Its great successes have all been based on detailed knowledge of cellular and molecular mechanisms. The development of drugs and vaccines combated infectious diseases. The discovery of penicillin in 1928 ushered in the era of antibiotics. Psychoactive drugs transformed the care of the mentally ill, replacing external coercion with the subtle internal chains of medication, though controlling symptoms without effect on underlying disorders. Endocrinology yielded insulin, cortisone, and the contraceptive pill. Medical technology reached unprecedented sophistication. Blood groups, transfusion, antibiotics, organ transplants. Yet we are now witnessing a profound crisis in healthcare. Despite a staggering increase in costs, the health of the population has not improved significantly. The relation between medicine and health is difficult to assess because statistics use the narrow biomedical definition of health as the absence of disease. A comprehensive view would show that eliminating certain diseases has not restored health. In the holistic view, physical disease is only one of several manifestations of a basic imbalance of the organism, which may express itself through psychological or social pathologies. Psychological and social pathologies have become major public health problems. Some 25% of the population is seriously handicapped psychologically, and there has been an alarming rise in alcoholism, violent crime, accidents, and suicide. The increase in life expectancy is often cited as proof of medicine's benefits, but this is misleading. Health has many dimensions and can never be represented by a single parameter. The increase in life expectancy resulted primarily from a decline in infant mortality related to poverty, nutrition, and social factors, and medical care has played almost no role in its decline. The seemingly contradictory statements of experts become intelligible when we realize they refer to different phenomena. Some mean progress in unraveling biological mechanisms. Others are talking about healing rather than scientific knowledge. The two kinds of progress are not incompatible. Biomedical research will remain important while being integrated into a broader approach. The biomedical approach has been highly successful in emergencies, accidents, acute infections, but does not make a significant difference for the health of populations as a whole. The dramatic decline in infectious diseases, for which medicine is usually given credit, was due mainly, as Thomas McEwen has shown, to improved nutrition, hygiene, and sanitation. The infectious diseases peaked and declined well before the first effective antibiotics and immunization techniques were introduced. The health of human beings is determined predominantly not by medical intervention, but by their behavior, food, and environment. The acute infectious diseases of the 19th century have been replaced in industrialized countries by the chronic and degenerative diseases of civilization. Heart disease, cancer, diabetes, related to stressful attitudes, rich diet, drug abuse, sedentary living, and environmental pollution. Physicians, unable to deal with these within the biomedical framework, treat them as inevitable wear and tear. The public, noticing exorbitant costs without improved health, complains that doctors treat diseases but are not interested in patients. Increasing numbers of people see the crisis as rooted in the conceptual framework of medical theory and practice, the biomedical model itself. The model and practice, psychiatry, technology, and intervention. The biomedical model is firmly grounded in Cartesian thought. A healthy person was like a well-made clock, a sick person a clock whose parts did not function properly. Following this approach, medical science limits itself to the biological mechanisms of injury, leaving out all non-biological influences. Out of the large network of phenomena that influence health, it studies only a few physiological aspects. As Donald Fredrickson of the National Institutes of Health puts it, the reduction of life to certain fundamentals that can then be resynthesized is the basic concern of biomedical research, proceeding to smaller and smaller fragments, from organs to cells to molecules, until the original phenomenon is lost. Confronted with environmental or social problems, medical researchers argue these are outside the boundaries of medicine. But doctors have played a major part in this dilemma by insisting they alone determine what constitutes illness. Public health interests are isolated from medical education, and issues crucial to health, nutrition, employment, housing, are not discussed in medical schools. There is little room for preventive health care. The phenomenon of healing will remain excluded from medical science as long as researchers cannot deal with the interplay of body, mind, and environment. The extension of the biomedical model to mental disorders has been unfortunate. Psychiatric diagnosis tries to establish a reductionist classification. Treatment is by medication that controls symptoms without curing, and from a holistic perspective, mental illness appears as a failure to evaluate and integrate experience. The symptoms reflect the organism's attempt to heal itself, and standard practice interferes with this spontaneous healing by suppressing them. Thomas Zaz, who regards mental illness as pure myth, takes the extreme position. In a holistic sense, taking account of the patient's entire organism and environment, mental disorders are as real as physical illnesses. The Cartesian division also leads medicine to avoid the philosophical and existential issues of illness. What is health is not addressed in medical schools. Disease is viewed as an enemy to be conquered, and researchers pursue the utopian ideal of eliminating all disease, failing to see, as Dubos notes, that complete freedom from disease is almost incompatible with the living process. The ultimate existential issue, death, is avoided as much as possible. Within the mechanistic framework, death cannot be qualified, becoming simply the standstill of the body machine. The art of dying is no longer practiced, and doctors, significantly more afraid of death than others, see death as a failure. The mechanistic view of the organism encouraged an engineering approach to health, illness as mechanical trouble, therapy as technical manipulation. This has alleviated much suffering but distorted our view of health. The public image of the body, enforced by advertising, is a machine prone to constant failure unless supervised by doctors. Ironically, physicians themselves suffer most from this view. Their life expectancy is 10 to 15 years less than average, with high rates of alcoholism, drug abuse, and suicide. Medical education, fiercely competitive, presents an aggressive approach to patient care, with illness described in the language of warfare. A tumor invades, radiation bombards and kills. Hard technology has taken a central role. The ratio of supporting personnel to doctors has risen from 1 to 2 to as high as 15 to 1. The practice of medicine has shifted from the physician's office to the depersonalized hospital, where 30 to 50% of hospitalization is medically unnecessary. Costs rose from $12 billion in 1950 to $160 billion in 1977. 1 out of every 5 patients in a research hospital acquires an iatrogenic illness. The malpractice crisis, with its defensive medicine, further increases costs and risks. Disease, drugs, and the definition of illness. At the center of contemporary healthcare is the biomedical definition of disease. Diseases are well-defined entities with unique causal roots, and researchers adhere to the doctrine of one disease, one cause, the germ theory first, then the molecular concept of the single lesion, then environmental causes. This theory has been successful in a few special cases, but cannot account for the overwhelming majority of illnesses. The main error of the biomedical approach is the confusion between disease processes and disease origins. Instead of asking why an illness occurs, researchers study the mechanisms through which it operates, then interfere with them. As McEwen emphasizes, the most fundamental question in medicine is why disease occurs rather than how it operates after it has occurred. Origins generally lie in several causative factors that must concur, and their effects differ from person to person depending on emotional reactions and social environment. The common cold depends on the receptive state of the exposed individual, and the same holds, far more seriously, for cancer, where the 1 in 1,000 exposure to disease ratio shows that the organism as a whole, including psychological and social conditioning, is involved. The classification of diseases patterned after the taxonomy of plants and animals is extremely problematic for mental illness, where diagnosis is necessarily subjective. In reducing illness to disease, physicians moved away from the patient as a whole person. Illness is a condition of the total human being, disease of a particular part of the body. Clinical experience shows one can be ill without having a disease. Half of all visits to the doctor are for complaints with no physiological disorder. Each disease itself can be seen as a symptom of an underlying illness whose origins are rarely investigated. The most striking example of the emphasis on symptoms rather than causes is the drug approach, rooted in the view that bacteria are the primary causes of disease rather than manifestations of underlying disorder. The overemphasis on bacteria gave rise to the view that disease is an attack from outside rather than a breakdown within. The grotesque image, promoted by the chemical industry, of a world where microbes are always trying to get at us. In fact, most bacteria are harmless or beneficial. The development of infectious disease depends as much on the response of the host as on the characteristics of the bacteria. In most cases, the damage is caused by an overreaction of the organism, a panic in which unrelated defense mechanisms are turned on at once, a lack of coordination within rather than injury from without. Drugs have become the key to all medical therapy, but their overuse and misuse has made adverse drug reactions a public health problem of alarming proportions. It has been argued that high-quality medicine can be practiced without any of the 20 most commonly prescribed drugs. The central justification that effective drugs come from plants overlooks a crucial difference. Purified chemical drugs are less efficient and more hazardous than the original remedies, whose trace elements limit the effect of the main ingredient and prevent resistant strains from developing. Modern science is now validating the empirical knowledge of folk healers. The engineering approach holds that cure requires outside intervention, without taking account of the healing potential within the patient, a direct consequence of the Cartesian view of the body as a machine requiring repair. Fragmentary intervention can be successful in the short run, while unhealthy in the long run. Surgery on a blocked artery treats a local effect of a systemic disorder. Therapy could instead be a subtle interference that stimulates the organism to complete the healing process itself, based on a respect for self-healing and on the patient as a responsible individual. Under the biomedical model, only the doctor knows what is important for health. His authority makes him assume a paternal role, perpetuating sexist attitudes. Nurses, though often highly trained, are considered assistants and their healing knowledge undervalued. Society has conferred on physicians the exclusive right to determine what constitutes illness, while healers of other coherent conceptual models, homeopaths, chiropractors, herbalists, are legally excluded. Medical education and the Cultural Revolution. The essential aspects of contemporary healthcare are determined by medical education, which was cast into its present form by the Flexner Report of 1910, commissioned by the American Medical Association with the aim of putting medical education on a sound scientific basis and channeling foundation funds into chosen institutions, establishing the link between medicine and big business that has dominated the healthcare system ever since. The modern medical school was to be part of a university, its primary purpose the education of students and the study of disease, not the care of the sick. The science taught was firmly embedded in the reductionist biomedical framework, dissociated from social concerns. Only about 20% of medical schools met the standards. The others, the institutions that had admitted women, blacks, and poor students, were forced to close. Scientific medicine became more and more specialized and hospital-based. Students were removed from contact with the illnesses of daily life, and the proportion of general practitioners fell from more than half to under a quarter. The task of the general practitioner requires wisdom, compassion, and sensitivity to the patient's emotional problems. But medical training presents the identification of a specific disease as the essence of care and vigorously promotes an imbalanced macho value system, suppressing intuition and nurturance. Research funding heavily favors the biological orientation promoted by the interest groups of the health industry. The biomedical model has become more than a model. Among the profession, it is a dogma. For the general public, it is the dominant folk model of illness. Patients are conditioned to believe that the doctor alone knows what made them sick and that technological intervention is the only thing that will make them well, making it very difficult for progressive physicians to change the patterns of care. To go beyond the model will require nothing less than a profound cultural revolution. The approach will remain useful, as the Cartesian-Newtonian framework remains useful, as long as its limitations are recognized. Biomedical research will have to be integrated into a broader system of healthcare, in which human illness is seen as resulting from the interplay of mind, body, and environment. This requires a major public re-education. Many people adhere to the biomedical model because they are afraid to examine their lifestyles, and as a society, we use medical diagnosis as a cover-up of social problems. We prefer to talk about our children's hyperactivity rather than the inadequacy of our schools, about hypertension rather than our over-competitive business world. These health problems go far beyond medicine, but they are brought into focus as soon as we seriously try to go beyond current medical care, Transcending the biomedical model is linked, ultimately, to the entire social and cultural transformation. The biomedical model, the conceptual foundation of modern medicine, the body as machine, disease as the breakdown of a mechanism, the doctor's task as repair, 3 centuries old and now the source of the health crisis. The exclusion of healing. Healing cannot be understood in reductionist terms, so it is excluded from medical science, the model's most serious shortcoming. Specific etiology, the doctrine of one disease, one cause, triumphant since Pasteur and Koch, but a serious flaw, confusing disease processes with disease origins. The health crisis, medicine's contribution to health is minimal. Nutrition and sanitation, not intervention, conquered the infectious diseases. The diseases of civilization now dominate. Illness versus disease. Illness is a condition of the total human being, disease of a part. Half of all visits to the doctor are for complaints with no physiological disorder. The Flexner Report, the 1910 reform that tied medicine to big business, made it reductionist and hospital-based, excluded women and minorities, and created the modern medical education. Medical scientism and the paternal role. The mystique of the doctor that devalues nursing and alternative healers, and the cover-up of social problems by medical diagnosis. Quote, the notion of the body as a machine, of disease as the consequence of breakdown of the machine, and of the doctor's task as repair of the machine. George Engel, as quoted by Capra, quote, complete freedom from disease and struggle is almost totally incompatible with the living process. René Dubos, as quoted by Capra, quote, the most fundamental question in medicine is why disease occurs rather than how it operates after it has occurred. Thomas McEwen, as quoted by Capra. 6. Newtonian psychology. The Cartesian division and the origins of scientific psychology. Like biology and medicine, psychology has been shaped by the Cartesian paradigm. Psychologists, following Descartes, adopted the strict division between the residential cogitans and the res extensa, which made it extremely difficult for them to understand how mind and body interact. The current confusion about the role of mind as distinct from brain is a manifest consequence of the Cartesian division. Descartes suggested different methods for studying the two realms, the mind by introspection, the body by the methods of natural science. His successors adopted both methods for the psyche, creating two major schools. The structuralists, who analyze consciousness by introspection into its basic elements, and the behaviorists, who concentrated exclusively on behavior, and so were led to deny the existence of mind altogether. Both emerged when scientific thought was dominated by the Newtonian model, and both modeled themselves after classical physics. Meanwhile, working in the clinic rather than the laboratory, Freud developed psychoanalysis with free association, a revolutionary theory of the mind whose basic concepts were again Newtonian. Thus, the three main currents of early 20th century psychology, 2 in the academy, 1 in the clinic, were based not only on the Cartesian paradigm, but on specifically Newtonian concepts of reality. The historical roots of psychology go back to Greek antiquity, and the Western belief that this tradition produced the only serious psychological theories is now recognized as a culturally conditioned view. The spiritual traditions of India and the East, grounded in mystical experience, have developed refined models of consciousness that cannot be understood within the Cartesian framework, but agree surprisingly with recent science. Vedanta, yoga, Buddhism, and Taoism are ways of liberation, resembling psychotherapies more than religions. The Greek psychological speculations, notably Descartes' own, were further developed by the empiricist philosophers. The concept of association allowed philosophers to reduce mental functioning to elementary rules. Hume saw it as an attraction in the mental world comparable to gravity, reducing the self to a bundle of perceptions. Hartley combined association with a neurological reflex into a mechanistic model of mind. In the 1870s, this model was incorporated into the work of Wilhelm Wundt, founder of the first psychology laboratory, the chief representative of the elementist orientation, all mental functioning analyzed into specific elements. The modern science of psychology was a result of 19th-century anatomy and physiology, which reformulated the naive mechanistic models of Descartes, L'Homme and Hartley in modern terms, and firmly established the Newtonian orientation. The discovery of correlations between mental activity and brain structure led to the hypothesis of localized mental faculties, which could not be sustained for higher cognitive processes. Reflexology, from Sechenov to Pavlov's conditioned reflexes, made the reflex the elementary building block of behavior. Weber and Fechner formulated a mathematical law relating sensation to stimulus. And Wundt's experimental program reached its peak. Opposition to these reductionist and materialistic theories came from psychologists who emphasized the unitary nature of consciousness. Gestalt psychology, founded by Wertheimer, held that organisms perceive not isolated elements, but meaningful wholes whose qualities are absent in their parts. Goldstein applied the Gestalt view to brain disorders in an organismic approach. Functionalism, a consequence of evolutionary thought, turned from mental structure to mental process, emphasizing the unity and dynamic nature of the stream of consciousness. Its foremost exponent was William James, founder of the first American psychology laboratory, who insisted consciousness is a personal, integral, continuous phenomenon. The elements of psychology were merely arbitrary cross-sections of a stream of thought. James later turned to the study of unusual states of consciousness, psychic phenomena, and religious experience, probing the full range of human consciousness. Our normal waking consciousness is but one special type of consciousness. Whilst all about it, parted from it by the filmiest of screens, there lie potential forms of consciousness entirely different. Neither Gestalt psychology nor functionalism could change the Newtonian orientation of the majority, but both strongly influenced the new trends of the second half of the century. Behaviorism, psychology without consciousness. In the 20th century, psychological thinking was dominated by behaviorism and psychoanalysis, which differed in methods and in their views of consciousness, but adhered to the same Newtonian model. Behaviorism represents the culmination of the mechanistic approach, a psychology without a soul, a sophisticated version of L'Homme human machine. Mental phenomena reduced to patterns of behavior to physiological processes. John Watson, its founder, was influenced by Titchener's rigorous structuralism, which reduced the contents of consciousness to simple elements, and by Loeb's mechanistic biology with its theory of tropism, forced movements imposed on organisms by the environment. Watson's behaviorism identified psychology with the study of behavior, applying to humans the procedures found useful with animals. Man is an animal different from other animals only in the types of behaviors he displays. To raise psychology to an objective natural science, Watson adhered to the methods of Newtonian mechanics, excluding the concept of consciousness and all related terms, mind, thinking, feeling, from psychology. It would have been a great shock to him that a few decades later the physicist Eugene Wigner would write that it was not possible to formulate the laws of quantum theory consistently without reference to consciousness. In the behaviorist view, organisms were complex machines reacting to external stimuli, a stimulus-response mechanism modeled after Newtonian physics, with complex phenomena reducible in principle to combinations of simple stimuli and responses, the conditioned response becoming an adequate explanation of all human expression, including science, art, and religion. The determinants of psychological phenomena were sought in the external world. Behaviorism became a psychology of learning, with conditioning its main method and behavioral engineering applying the Baconian ideal of domination and control to human beings. The classical phase of behaviorism, dominated by Watson, produced an enormous amount of experimentation but no comprehensive theory. Clark Hull tried to construct one, formulated like Newton's Principia as a system of definitions and postulates, with the principle of reinforcement at its core. He was replaced by B.F. Skinner, whose main innovations were an operational definition of reinforcement and precise schedules of reinforcement, tested through operant conditioning in simplified environments, Skinner boxes, and pecking pigeons. Skinner regarded mind and ideas as non-existing entities invented to provide spurious explanations. The only serious explanations are mechanistic, satisfying the criteria of Newtonian physics. His concepts were based almost exclusively on conditioning experiments with rats and pigeons, reduced, as Paul Weiss put it, to puppets operated by environmental strings, from which he made a huge conceptual leap to human behavior, proposing an engineering approach to create a new type of man, not through an evolution of consciousness, which does not exist, but through scientific control of behavior. What we need, he wrote, is a technology of behavior, comparable in power and precision to physical and biological technology. This is Newtonian psychology par excellence. A psychology without consciousness that reduces all behavior to mechanistic sequences of conditioned responses, reflecting our culture's preoccupation with manipulative technology designed for domination and control. Psychoanalysis, the Newtonian mind. Psychoanalysis came from psychiatry, which in the 19th century was committed to the biomedical model and the search for organic causes of mental disturbance. When Charcot showed that the symptoms of hysteria could be produced and removed by hypnotic suggestion, the organic approach was called into question. Freud, who went to Paris to witness Charcot's demonstrations, began with Breuer to use hypnotic technique, then free association, the cornerstone of the psychoanalytic method. Trained as a neurologist, Freud believed all mental problems could in principle be understood in terms of neurochemistry. But neurological science was not advanced enough, so he pursued a different avenue. Over 30 years, he produced a continuous flow of creativity. He discovered the unconscious and its dynamics. Consciousness, a thin layer resting on a vast unconscious governed by instinctual forces, hence depth psychology. He identified the libido as a principal psychological force, extending the concept of sexuality to infancy. He developed the interpretation of dreams, the royal road to the unconscious. And in his second phase, he formulated the theory of personality based on ID, ego, and superego, and discovered transference. Freud was deeply concerned with establishing psychoanalysis as a science, insisting on its descent from physics and medicine. Analysts are at bottom incorrigible mechanists and materialists, though unlike many followers, he knew scientific models were limited and open to revision. The close relation between psychoanalysis and classical physics is strikingly apparent in the four sets of concepts of Newtonian mechanics: absolute space and time with separate material objects, fundamental forces distinct from matter, fundamental laws expressed in quantitative relations, rigorous determinism, and objective description, which correspond to the four basic perspectives of psychoanalysis: the topographic, dynamic, economic, and genetic points of view. As Newton established absolute space as the frame of reference for material objects, so Freud established psychological space for the structures of the mental apparatus. ID, ego, and superego are internal objects located and extended in psychological space. Hence the spatial metaphors of depth psychology and Freud's advice to be cold as a surgeon. The dynamic aspect mirrors Newtonian dynamics. Psychological objects interact through forces essentially different from matter: drives and defenses, libido and destrudo, eros and thanatos. Forces defined by their effects, their intrinsic nature uninvestigated, just like Newton's gravity. The economic aspect attached quantities of emotional energy to the mental images, the mental energy exchange being crucial to conflicts. The final outcome of the struggle depends on quantitative relations. The genetic approach traced symptoms back along a linear chain of cause and effect, every psychological event uniquely determined by its initial conditions. And the notion of the objective observer was reflected in the analytic arrangement. The patient on the couch, the invisible therapist objectively observing, Freudian therapy neglecting the body as medical therapy neglects the mind. In practice, Freud was less rigid than his theory. He recognized that analytic observation was a powerful intervention, that prolonged analysis produced a transference neurosis, depending on the interaction between therapist and patient, and he came to emphasize personal influence as our most powerful dynamic weapon. The Freudian legacy and its limits. The classical theory of psychoanalysis brilliantly integrated Freud's discoveries into a framework satisfying the science of his time. Its shortcomings are due partly to the limits of the Cartesian-Newtonian framework, partly to Freud's own cultural conditioning. Recognizing them does not diminish the genius of its founder, but is crucial for the future of psychotherapy. Recent developments recognize the Freudian model as extremely useful for certain levels of the unconscious, but severely limiting for the totality of mental life. The situation is not unlike physics, where the Newtonian model is useful within a range but must be radically changed beyond it. Freud's immediate followers pointed the way. Adler rejected the dominant role of sexuality, emphasizing the will to power and compensation for inferiority, the social roots of mental disorders, and the first feminist critique of Freud's female psychology. Reich discovered the character armor, mental attitudes expressed in muscular patterns, and associated libido with concrete energy flowing through the organism, breaking the taboo against touching and developing bodywork. Rank put primary emphasis on the trauma of birth, having patients relive rather than merely remember it. Jung went furthest, transcending mechanistic models and bringing psychology closer to modern physics than any other school, aware that the rational approach of Freud would have to be transcended to explore the subtler aspects of the psyche. Freud's strictly rational and mechanistic approach made it especially difficult for him to deal with religious and mystical experience. He equated religion with ritual, seeing it as an obsessive-compulsive neurosis of mankind. In the Freudian model, there is no room for altered states of consciousness, which occur spontaneously far more often than is believed and have often been labeled psychotic symptoms by psychiatrists unable to incorporate them into their framework. Here, an awareness of modern physics could have a very salutary effect on psychotherapy. Physicists have adopted concepts that contradict common sense and the principles of Newtonian science, yet are scientifically sound, and knowledge of these concepts and of their similarities to those of mystical traditions may well make it easier for psychiatrists to go beyond the traditional Freudian framework in dealing with the full range of human consciousness. The Cartesian division in psychology: introspection for the mind, natural science for the body, spawning the structuralists and the behaviorists, both Newtonian at the core. The elementist orientation: Wundt's program of analyzing all mental functioning into specific elements, modeled on the atomistic physics of the time. Gestalt psychology and functionalism: the holistic reactions, meaningful wholes against isolated elements. James's stream of consciousness against atomistic analysis. Behaviorism: psychology without a soul, mental phenomena reduced to behavior to physiological processes, culminating in Skinner's technology of behavior for domination and control. The Newtonian structure of psychoanalysis: the topographic, dynamic, economic, and genetic points of view mirroring absolute space, fundamental forces, quantitative laws, and determinism. The four renegades: Adler, Reich, Rank, and Jung, each transcending a different part of the Newtonian framework, from social roots to birth trauma to the collective unconscious. Quote, "Our normal waking consciousness, rational consciousness as we call it, is but one special type of consciousness, whilst all about it, parted from it by the filmiest of screens, there lie potential forms of consciousness entirely different." William James, as quoted by Capra, quote, "What we need is a technology of behavior, comparable in power and precision to physical and biological technology." B.F. Skinner, as quoted by Capra, quote, "Analysts are at bottom incorrigible mechanists and materialists." Sigmund Freud, as quoted by Capra. 7. The impasse of economics. The Cartesian flaw of the social sciences. The triumph of Newtonian mechanics established physics as the prototype of a hard science against which all others were measured. The closer scientists came to emulating its methods, the higher the standing of their discipline. In our century, this tendency has become a severe handicap in many fields, but most of all in the social sciences, whose practitioners have tried hard to gain respectability by adopting the Cartesian paradigm. The Cartesian framework, however, is often quite inappropriate for the phenomena they describe, and their models have become increasingly unrealistic, nowhere more apparent than in economics. Present-day economics is characterized by the fragmentary, reductionist approach that typifies most social sciences. Economists generally fail to recognize that the economy is merely one aspect of a whole ecological and social fabric, a living system composed of human beings in continual interaction with one another and with their natural resources, most of which are, in turn, living organisms. The basic error of the social sciences is to divide this fabric into fragments assumed to be independent, dealt with in separate academic departments. Political scientists neglect economic forces. Economists fail to incorporate social and political realities. Those critical economists who wish to study economic phenomena as they actually exist, embedded within society and the ecosystem, were virtually forced to place themselves outside economic science, saving the economics fraternity from dealing with the issues their critics raised. Max Weber is regarded as an economic historian, Galbraith and Heilbronner as sociologists, Boulding as a philosopher. Marx refused to be called an economist, and Hazel Henderson calls herself a futurist, subtitling one of her books, The End of Economics. Another aspect severely neglected is the economy's dynamic evolution. Classical physics applies to an unchanging range of phenomena. Biological evolution proceeds over very long time spans, but the evolution of economic patterns takes place at a much faster pace. An economy is a continually changing and evolving system, dependent on the changing ecological and social systems in which it is embedded. And to understand it, we need a conceptual framework capable of change and continual adaptation. Sadly lacking in the work of most contemporary economists, fascinated by the rigor of the Cartesian paradigm and the elegance of Newtonian models, and increasingly out of touch with economic realities. The evolution of a society, including its economic system, is closely linked to changes in its value system. The values a society lives by determine its worldview, its institutions, its science and technology, its political and economic arrangements. The study of values is of paramount importance for all social sciences. There can be no such thing as a value-free social science. Those who consider values non-scientific are attempting the impossible. Any value-free analysis is based on the tacit assumption of an existing value system implicit in the selection and interpretation of data, and by avoiding the issue, they are less scientific, laying themselves open to the Marxist critique that all social sciences are ideologies in disguise. Economics, dealing with the production, distribution, and consumption of wealth, is the most clearly value-dependent and normative among the social sciences. Its models are always based on a certain value system and a certain view of human nature, a body of assumptions Schumacher calls meta-economics. He illustrated the value dependence of economics by comparing our materialist system, in which the standard of living is measured by annual consumption and which therefore maximizes consumption, with a system of Buddhist economics based on right livelihood and the middle way, aiming at a maximum of human well-being with an optimal pattern of consumption. Contemporary economists, in a misguided attempt at scientific rigor, have avoided unstated values. Boulding called the attempt a monumentally unsuccessful exercise, retreating to easier but less relevant problems and disguising value conflicts with technical language, converting social and moral choices into pseudo-technical cost/benefit analyses that conceal conflicts resolvable only politically. The only values appearing in current models are those quantifiable by monetary weighting, which gives economics the appearance of an exact science, while excluding the qualitative distinctions crucial to the ecological, social, and psychological dimensions of economic activity. Energy is measured only in kilowatts. No distinction is made between renewable and non-renewable goods, and social costs are added as positive contributions to the GNP. The result is a tremendous gap between theory and economic reality. Economics is in profound conceptual crisis. Global inflation and unemployment, maldistribution of wealth, and energy shortages are now painfully visible, and the failure of the profession is recognized by a skeptical public, by other scientists, and by economists themselves. Opinion polls showed a drastic decline of confidence in business institutions. 75% believed major companies had become too powerful. Economists acknowledged the impasse. Friedman confessed, "We economists in recent years have done vast harm by claiming more than we can deliver." Blumenthal declared the profession close to bankruptcy in understanding the present situation. Most economists still believe solutions can be found within the existing framework, but that framework is based on concepts and variables that originated several hundred years ago and have been outdated. The crisis will be overcome only if economists participate in the paradigm shift now occurring in all fields, a shift that will not make the new approaches less scientific, but more consistent with the natural sciences. Economics, with its basic focus on material wealth, is the quintessential expression of sensate values. The system overemphasizes material acquisition, expansion, competition, and hard technology, institutionalizing the deadly sins of gluttony, pride, selfishness, and greed. The history of economic thought. Until the 16th century, there was no isolation of purely economic phenomena from the fabric of life. Resources were produced for use value and distributed reciprocally within groups. Markets were local and based on barter. Even early trading was often a sacred and ceremonial activity, like the Trobriand Islanders' circular voyages without profit motives. The motive of individual gain was generally absent, the very idea of profit or interest band. An important principle was householding, the Greek oikonomia, the root of our term economics, under which private property was justified only as it served the welfare of all. The word private comes from pravari, to deprive, showing the ancient view that property was first and foremost communal. With the scientific revolution and the Enlightenment, critical reasoning, empiricism, and individualism became the dominant values, and economic activities stood out in sharp relief, requiring description, explanation, and rationalization. One of the most important consequences was the rise of capitalism. According to Max Weber's ingenious thesis, the capitalist mentality was closely related to the religious idea of a calling emerging with Luther and the Reformation, emphasized by the Puritan sects, which saw worldly activity and material reward as signs of divine predestination. The Protestant work ethic, in which hard, self-denying work and worldly success were equated with virtue, while frugal consumption made accumulation of wealth legitimate. Weber's tradition of criticizing economic activity on the basis of its underlying values provided avenues for later critics, and the feminist critique has focused on the patriarchal value system underlying virtually all economies, pointing out that patriarchal attitudes are far older than capitalism and that socialist movements themselves exhibit an overwhelming male bias. Modern economics is a little over 300 years old, founded by Sir William Petty, whose political arithmetic owed much to Newton and Descartes, replacing words and arguments by numbers, weights, and measures. He put forth the labor theory of value, the division of labor, and the quantity of money, anticipating Keynes by 2 centuries. John Locke laid further foundations. His atomistic theory of society led to representative government safeguarding property rights, and his idea that prices were determined objectively by demand and supply liberated merchant from the moral law of just prices, elevating supply and demand to a cornerstone of economics equal to the laws of mechanics. The law of supply and demand fit perfectly with the mathematics of Newton and Leibniz, becoming the basis of efforts to turn economics into an exact mathematical science. The French physiocrats, first to call themselves economists, claimed that only agriculture and the land were truly productive of wealth, introducing the doctrine of laissez-faire. The period of classical political economy was inaugurated in 1776 when Adam Smith published The Wealth of Nations. Smith held that the true base of wealth is production from human labor and natural resources, increased above all by the division of labor. From the Newtonian idea of natural law, he deduced that it was human nature to barter and exchange. From the physiocrats, he adopted laissez-faire, immortalized in the metaphor of the invisible hand, which would guide individual self-interest for the harmonious betterment of all, a social result independent of individual intentions, making an objective science of economic activity possible. He based his theory on the Newtonian notions of equilibrium, laws of motion, and scientific objectivity. Neglecting the problem of friction, he imagined the balancing mechanisms of the market would be almost instantaneous, with prices gravitating in the proper direction, small producers and consumers meeting with equal power and information. This idealistic picture underlies the competitive model widely used today. Perfect and free information, buyers and sellers too small to influence price, complete and instant mobility, conditions violated in the vast majority of today's markets, yet used by economists almost unconsciously, having become a picture of how the world really is. For international trade, Smith developed the doctrine of comparative advantage. The idea of continual growth was adopted by succeeding generations, who paradoxically used mechanistic equilibrium assumptions while postulating continuing growth. David Ricardo introduced the concept of an economic model, a logical system of postulates and laws. Central to his system was the idea that progress would end because of the rising cost of growing food on limited land, developing the concept of marginal land that became the basis of marginal analysis. His efforts consolidated economics into dogmas supporting the existing class structure. Welfare economics shifted focus to subjective criteria of pleasure and pain. Pareto's optimality still neglected unequal power, information, and income, and individual preferences cannot be added up into social choice. The utopians set up factories and mills according to humanitarian principles. Reduced hours, increased wages, insurance, but all ultimately failed in a hostile environment. John Stuart Mill came to a radical conclusion. Economics had only one province, production and the scarcity of means. Distribution was a political process. This narrowed economics to pure neoclassical economics, excluding social and environmental variables in analogy to the controlled experiments of the physical sciences, the split that led to today's disastrous confusion, with policy tools derived from abstract, unrealistic mathematical models. Marx and the organic view. Anyone who seriously tries to understand the social condition of humankind has to deal with the continuing intellectual fascination of Marx. As Heilbronner puts it, Marx was the first to discover a whole mode of inquiring that would forever after belong to him, that of social critique. That is why he referred to himself as a social critic rather than an economist. His main influence has been political. Judged by the number of worshipping followers, Marx must be considered a religious leader to rank with Christ or Muhammad. Economists have had to deal with, or ignore, his embarrassingly accurate predictions. The boom and bust business cycles, the reserve armies of unemployed, today usually consisting of ethnic minorities and women. Das Kapital is a thorough critique of capitalism from the explicitly stated perspective of the struggle between workers and capitalists. Marx recognized that capitalism would speed technological innovation and foresaw monopolies and depressions. His indictment of capitalism, the entanglement of all peoples in the net of the world market, the growing mass of misery, oppression, slavery, degradation, exploitation, has lost none of its power in our crisis-ridden, corporate-dominated global economy. The failure of socialism to take hold in the United States is often attributed to workers' high wages and identification with middle-class mobility. But there were other explanations. American workers were transient, divided by languages and ethnic differences that factory owners exploited, many returning to the old country. In the late 20th century, the Third World has taken on the role of the proletariat because of the multinational corporations, which play off workers in one country against another, exploiting racism, sexism, and nationalism. Marx used the labor theory of value to raise issues of justice. Since human labor creates all values, there will generally be a surplus. The surplus value, appropriated in capitalist societies by those who own the means of production. The transaction between people of unequal power turns money into capital. Marx's basic critique of neoclassical economics, as valid today as then, is that economists, narrowing their field to the economic core process, evade the ethical issue of distribution. They shifted from a measure of value to the much less burning question of relative prices. Marx's view of the role of nature in production was part of his organic perception of reality. As Michael Harrington has emphasized, a systems view often overlooked by critics who claim his theories are exclusively deterministic and materialistic. In dealing with reductionist arguments, he fell into the trap of expressing his ideas in scientific formulas, but his larger theory reflected a keen awareness of society and nature as an organic whole. Nature is man's inorganic body. Man is part of nature. He was aware of the ecological impact of capitalism. All progress in capitalist agriculture is progress in the art, not only of robbing the labor, but of robbing the soil. And his approach could have predicted the ecological exploitation that capitalism produced and socialism perpetuated, though Marxists have ignored the ecological marks, perhaps because other species do not provide revolutionary energies. Like most 19th century thinkers, Marx was concerned about being scientific, formulating his theories in Cartesian and Newtonian language. But he transcended the Cartesian framework. He did not adopt the stance of the objective observer, insisting his analysis was inseparable from critique. He revealed deep humanistic insights in his discussion of alienation. And he saw society as an organic whole in which ideology and technology were equally important. Keynes and the schools of modern economics. As mathematical economists refined their models, the world economy headed for the worst depression in its history, shaking the foundations of capitalism and seeming to verify all the Marxian predictions. After the Great Depression, government interventions based on the theory of John Maynard Keynes turned the wheel of capitalism's fortunes once more. Keynes viewed economic theory as an instrument of policy, making economics political again, deriving his policy interventions from the neoclassical model by demonstrating that economic equilibrium states were special cases, exceptions rather than the rule. Shifting from the micro level to the macro level, he established simplified relations among national income, consumption, investment, and employment, showing that fluctuating business cycles were an intrinsic property of national economies. In the Keynesian model, additional investment always increases employment and income, which eventually trickled down to the poor, though Keynes never said this would culminate in full employment. The crucial role of advertising follows. Consumers must keep increasing their spending predictably for the system to work. Today, the classical theory has been turned on its head. Economists of all persuasions create business cycles. Consumers are forced to become involuntary investors, and the market is managed by business and government, while neoclassical theorists still invoke the invisible hand. By the 1970s, the flaws of Keynesian economics had become apparent. It concentrates on the domestic economy, dissociating it from the global network. It neglects the power of multinational corporations, political conditions, and social and environmental costs. At best, it can provide scenarios, not predictions. Like most Cartesian economic thought, it has outlived its usefulness. Contemporary economics is a mixed bag of concepts from various epochs. The neoclassical Keynesian synthesis never took place. Neoclassical economists grafted Keynesian tools onto their own models, schizophrenically retaining the old equilibrium concepts. The post-Keynesians divide into supply-side economists, whose removal of unproductive environmental controls is manifestly anti-ecological, and those who reject the free market model and the invisible hand, recognizing the economy is dominated by massive corporate institutions, though they still use aggregated data, neglect to qualify growth, and lack an ecological view. All these models, Marxist as well as non-Marxist, are deeply rooted in the Cartesian paradigm, inappropriate to describe today's closely interrelated, continually changing global economy. The obsession with growth. One of the outstanding characteristics of today's economies, both capitalist and communist, is an obsession with growth. Unlimited expansion in a finite environment can only lead to disaster. The belief in continuing growth is a consequence of overemphasis on yang values, expansion, self-assertion, competition, and of the linear thinking that if something is good, more of the same will necessarily be better. The competitive approach is part of the legacy of Locke's atomistic individualism, which in America was vital to early settlers but has become unhealthy. The whole is identified with the sum of its parts, and the consequences of this reductionist fallacy are becoming painfully visible as economic forces collide, tear the social fabric, and ruin the natural environment. The global obsession with growth has produced a remarkable similarity between capitalist and communist economies. Both are dedicated to industrial growth and hard technology, with increasingly centralized control. The universal addiction to growth has become, to borrow Marx's phrase, the opium of the people. Growth is an essential feature of life. The Greek phusis and the Sanskrit Brahman derive from the root bu, to grow, but current notions lack any qualification. In a finite environment, there must be a dynamic balance between growth and decline. What we urgently need is differentiation and qualification of the concept of growth, channeling it from the private sector into public service areas, accompanied by a shift from material acquisition to inner growth. Economic growth is accepted as dogma, assumed to be the only way wealth will trickle down to the poor, a model long shown unrealistic. Its most severe consequence is the depletion of natural resources, predicted with mathematical precision by the geologist M. King Hubbard. The production/depletion curve for all non-renewable resources are bell-shaped, rising, peaking, declining, and petering out. Petroleum in the United States peaked in the 1970s, world petroleum around the 1990s. And the curves describe the depletion of every resource, from metals to oxygen and ozone. Population growth is equally driven by social factors. The quality of life, fulfillment of material needs, a sense of well-being, confidence in the future, becomes a powerful motivation for controlling fertility, producing a demographic transition to a balanced population. The Third World's population explosion continues because the conditions for this transition have not been met. The wealth generated in the colonies was diverted to the developed countries, and the exploitation continues today, an unanticipated effect of international exploitation, in which every exploitation comes back to haunt the exploiters. Ecological balance also requires social justice, and the cost of raising third-world living standards to the level that induces voluntary fertility limitation is small compared to the wealth of developed countries. Economic growth is inextricably linked with technological growth. Individuals and institutions believe every problem has a technological solution, from nuclear power to missiles and bombs, usually shifting problems around in the global ecosystem, with side effects more harmful than the original problem. The ultimate manifestation is the fantasy of space colonies. The basic fallacy is not technological, but the naive belief that space technology can solve the social and cultural crisis on this planet. Technological determinism, the belief that technology determines our values and social relations, is a consequence of the high status of science and fails to recognize that our values and social relations determine the nature of our technology. The young, masculine consciousness that dominates our culture has found its fulfillment in hard technology, fragmented, bent on manipulation and control, centralized, profoundly anti-ecological, antisocial, and inhuman. Its most dangerous manifestation is the expansion of nuclear weapons, the most expensive military boom in history. A third to a half of America's scientists work for the military, and the idea that psychological or social research, let alone philosophy or poetry, could be relevant is never mentioned. National security is analyzed in terms of power blocks and action and reaction, Newtonian notions. The complexity of industrial systems has reached a point where they can no longer be modeled or managed. As Henderson has pointed out, we may reach the social, psychological, and conceptual limits to growth before the physical limits. What we need is a redefinition of technology. We have concentrated too much on hard, resource-intensive technologies and must shift to the soft technologies of conflict resolution, cooperation, and recycling. As Schumacher says, a technology with a human face. Corporate power and institutional growth. The third aspect of undifferentiated growth is the growth of institutions. Whatever the original purpose, growth beyond a certain size invariably distorts it, making self-preservation and expansion the overriding aim, while people feel increasingly alienated. The most dangerous manifestation is the growth of corporations. The largest have transcended national boundaries, their assets exceeding the gross national products of most nations, their power surpassing that of many governments. In the United States, corporate power permeates every facet of public life. The nature of large corporations is profoundly inhuman. Competition, coercion, and exploitation motivated by the desire for indefinite expansion. Executives who bypass an opportunity to increase profits liable to lawsuit, unable to say, "I am sorry," or "we made a mistake." Yet there are no laws to deal with them. Laws made for humans are applied to corporations that have lost all resemblance to human beings. The effects are disastrous in the third world, where multinationals extract natural resources, produce cash crops for export instead of food, and sell dangerous products outlawed in the United States. Large-scale corporate crime is the most widespread and least prosecuted criminal activity. Many large corporations are now obsolete institutions. The automobile industry cannot adjust to the need to restructure transportation, and the utility companies campaign for nuclear power rather than the decentralized solar technology conducive to our survival. The question of scale, which Schumacher pioneered with the slogan "Small is beautiful," will play a crucial role in the reassessment of our economic system. The universal obsession with growth has been accompanied by an idolatry of gigantism. Size is relative, and our task is to achieve a balance between the two. Economists tend to freeze the economy in its current institutional structure instead of seeing it as an evolving system. As Henderson likes to say, we have reached a point where nothing fails like success. Our economic and institutional structures are dinosaurs. Today's world economy is based on past configurations of power, perpetuating class structures, and the exploitation of third-world countries. In the United States, 76% of corporate securities are owned by 1% of the stockholders, while 10% of the people own only 8% of the nation's wealth, an inequality built into the structure of the system. The avoidance of social issues is closely related to the inability of economists to adopt an ecological perspective. The main body of economic thought is inherently anti-ecological, treating all goods equally. $10 worth of coal equals $10 worth of bread or education, reducing all values to the single criterion of private profit. Social and environmental costs are labeled external variables. Private profits are made increasingly at public costs in the deterioration of the environment and the quality of life. As Henderson writes, they tell us about the sparkling dishes and clothes, but forget to mention the loss of those sparkling rivers and lakes. Inflation, work, and the redefinition of economics. Economists' inability to see economic activities within their ecological context prevents them from understanding the major economic problems of our time, foremost among them inflation and unemployment. Inflation has several major sources involving variables excluded from economic models. As the resource base declines, raw materials must be extracted from ever more degraded reservoirs, requiring more capital, so the decline of natural resources is accompanied by an exponential climb of resource prices, one of the main driving forces of inflation. The economy is capital-intensive rather than labor-intensive. Capital is itself becoming scarce, yet there is a strong tendency to substitute capital for labor, a capital-intensive economy being resource and energy-intensive and thus highly inflationary. The American system of agriculture is a striking example. Energy-intensive machines and oil-based pesticides and fertilizers destroy the organic balance of the soil, yield diminishing returns, and make farmers victims of inflation. Animal farming takes 10 times more fossil fuel energy to produce a unit of animal protein than plant protein. The presumed trade-off between inflation and unemployment, the Phillips curve, is an abstract and unrealistic concept. Stagflation has become a structural feature of all industrial societies committed to undifferentiated growth. The second major cause of inflation is the ever-increasing social costs of undifferentiated growth. Individuals and institutions try to externalize all social and environmental costs, pushing them onto each other, the environment, and future generations, until they accumulate as the costs of litigation, crime control, bureaucratic coordination, regulation, and healthcare, none adding anything to real production. Free markets, balanced by supply and demand, exist only in textbooks. Oil companies shape national energy policy in corporate rather than national interest. As John Swearingen of Standard Oil said, "We're not in the energy business. We're in the business of trying to use the assets entrusted to us by our shareholders." To deal with economic phenomena from an ecological perspective, economists will need to revise their basic concepts. The gross national product adds up all monetary activities indiscriminately while ignoring non-monetary aspects. Social costs are added as positive contributions, education treated as expenditure, household work not counted. The concepts of efficiency, productivity, and profit are used in a narrow context. Corporate efficiency is measured by corporate profits made at public cost. We must ask efficient for whom? Utility companies declared solar energy inefficient because it could not compete in the free market after obtaining heavy subsidies themselves. The whole American industrial system, using the planet's resources for a tiny percentage of its population, is highly inefficient from a global ecological point of view. The notion of profit must be revised so that it becomes associated with the creation of real wealth. The artificial division of the economy into private and public sectors has led economists to ignore the link between private profits and public costs. The remapping of the economy will involve profound changes in our value system. Wealth itself must transcend its connotation of material accumulation and take the broader sense of human enrichment. Money alone no longer provides an adequate tracking system. An important aspect of the revision will be the redefinition of work. In our society, work is identified with a job done for an employer for money. Unpaid activities do not count. Yet the work performed in households equals 2/3 of all wages and salaries paid by American corporations. Those who have jobs often perform work in which they cannot take pride, profoundly alienated, as Marx recognized, because workers do not own the means of production and cannot identify with the production process. Most of the work carried out today is wasteful and unjustified. As Roshik has forcefully stated, work that produces unnecessary consumer junk or weapons of war is wrong and wasteful. There is no way to redeem such work by enriching, socializing, or decentralizing it. In traditional societies, ordinary men and women were engaged in a wide variety of useful, skilled, dignified work. In our society, work has become opposed to leisure, served by a huge industry of resource-intensive gadgets. There is an interesting hierarchy. Work with the lowest status is the most entropic: housework, services, agriculture, where the tangible evidence of the effort is most easily destroyed, jobs delegated to minority groups and women. High-status jobs create something lasting: skyscrapers, supersonic planes, space rockets, nuclear warheads. This hierarchy is exactly opposite in spiritual traditions, where high-entropy work is highly valued. Buddhist monks consider cooking and gardening part of their meditative activities. Doing work that must be done over and over again helps us recognize the natural cycles of growth and decay and become aware of the dynamic order of the universe. To reorganize our work in this way will allow us to recapture its spiritual essence. The inevitable revision of basic economic concepts raises the question whether economics, as a social science, will survive it. I believe the most useful approach is not to abandon economics, but to regard the framework of current economic thought, deeply rooted in the Cartesian paradigm, as a scientific model that has become outdated, useful for limited microeconomic analyses, but needing modification and expansion. The new theory will involve a systems approach integrating biology, psychology, political philosophy, and other branches of knowledge with economics into a broad ecological framework shaped by men and women who refuse to be labeled economists. Its empirical basis includes ecological data, social and political facts, psychological phenomena, and a clear reference to cultural values. Explicit reference to human attitudes, values, and lifestyles, making this new science profoundly humanistic, dealing with human aspirations and integrating them into the matrix of the global ecosystem. In its ultimate nature, scientific and spiritual at the same time. Meta-economics, Schumacher's name for the body of assumptions about values and human nature that underlies all economic theory, rarely stated explicitly. The invisible hand, Smith's metaphor for the market's self-balancing mechanism, an idealistic picture of frictionless equilibrium that became the unrealistic competitive model. Surplus value, Marx's key concept, the surplus over subsistence appropriated by capitalists. His critique of economics' evasion of the ethical issue of distribution remains valid. Undifferentiated growth, the obsession of both capitalist and communist economies. Unlimited expansion in a finite environment, related to Jung values and Newtonian notions of infinite space. Technological determinism, the belief that technology determines values and social relations, the reverse of the truth and the source of our hard, anti-ecological technology. Externalities, the social and environmental costs economists label external, pushed onto each other, the environment, and future generations, accumulating as inflation. Entropic work, the low-status, essential work whose evidence is easily destroyed, valued in spiritual traditions, despised in our own. The end of economics. Economic survival only through a systems approach integrating values into an ecological framework, scientific and spiritual at once. Quote, "We economists in recent years have done vast harm to society at large, and to our profession in particular, by claiming more than we can deliver." Milton Friedman, as quoted by Capra, quote, "Hand in hand with the centralization of capital grows the mass of misery, oppression, slavery, degradation, exploitation." Karl Marx, Das Kapital, as quoted by Capra, quote, "It's possible to know the price of everything and the value of nothing." Oscar Wilde, as quoted by Capra. 8. The dark side of growth. The chemical burden. The mechanistic Cartesian worldview has had a powerful influence on all our sciences and on the general Western way of thinking. The method of reducing complex phenomena to basic building blocks has become so deeply ingrained that it has often been identified with the scientific method. Ideas that did not fit into the framework of classical science were not taken seriously. As a consequence, our culture has become progressively fragmented and has developed technologies, institutions, and lifestyles that are profoundly unhealthy. This is not surprising in view of the connection between health and whole. Both words like hail, heal, and holy derive from the Old English how, meaning sound, whole, healthy. Our experience of feeling healthy involves physical, psychological, and spiritual integrity, a sense of balance among the components of the organism and between the organism and its environment, a sense lost in our culture, where the fragmented, mechanistic worldview and its one-sided, sensate, yang-oriented value system have led to a profound cultural imbalance and generated numerous symptoms of ill health. Excessive technological growth has created an environment in which life has become physically and mentally unhealthy. Polluted air, noise, traffic congestion, chemical contaminants, radiation hazards have become part of everyday life. Not incidental byproducts of progress, but integral features of an economic system obsessed with growth and expansion. Less obvious, but far more dangerous threats, because they affect us on a larger scale in space and time, are the ecological disruptions of human technology. The American public became acutely aware of the hazards of chemical waste with the tragedy of Love Canal, an abandoned trench in Niagara Falls used for years as a dump for toxic chemicals, which polluted surrounding waters, filtered into backyards, and generated toxic fumes, causing high rates of birth defects, liver and kidney damage, and cancer among the residents. Michael Brown's investigations made clear that Love Canal was only the first of many such tragedies. The EPA estimated more than 50,000 known hazardous waste sites, less than 7% properly disposed of. These wastes are a result of technological and economic growth. Obsessed with expansion and profits, industrial countries have developed societies of competitive consumers induced to buy, use, and throw away ever larger quantities of products of marginal utility, produced by resource-intensive technologies heavily dependent on complex chemicals. While the production of consumer goods was highly profitable, the treatment and recycling of residues was not, so the chemical industry dumped its waste in the ground for decades, creating thousands of dangerous dump sites, toxic time bombs among the most serious environmental threats of the 1980s. The chemical companies concealed the dangers, covered up accidents, and pressured politicians. But public awareness has increased. In the long run, the problems of chemical waste will be manageable only if we minimize the production of hazardous substances, which will involve radical changes in our attitudes as producers and consumers. Energy, coal, and nuclear power. Our excessive consumption and emphasis on high technology also require huge amounts of energy. Non-renewable fossil fuels power most production processes, and their decline has made energy scarce and expensive. Exorbitant petroleum use has led to heavy tanker traffic and oil spills disrupting marine food cycles. The generation of electricity from coal is even more hazardous. Underground mining damages miners' health, strip mining devastates the land, and the burning of coal emits vast quantities of toxic and carcinogenic gases, the most dangerous being sulfur dioxide, which severely impairs the lungs, and nitrogen oxide, the main ingredient in automobile air pollution. The sulfur and nitrogen oxides also generate the most insidious and invisible form of air pollution, acid rain. The gases turn into sulfuric and nitric acids carried by the wind and wash down to the earth, killing fish, insects, and plants. Thousands of lakes in Canada and Scandinavia are dead or dying. Technologies to reduce these pollutants exist, but the corporations that own the coal plants are opposed to environmental regulation. Rather than neutralizing their waste products, the industries simply dump them somewhere else, without caring that in a finite ecosystem there is no such place as somewhere else. The debate about the energy crisis is heavily biased. Solar energy, the only source that is abundant, renewable, stable in price, and environmentally benign, is said to be uneconomical, and the need for more energy is assumed unquestioningly. But our ever-increasing energy needs reflect the patterns of undifferentiated growth that deplete natural resources. What we need to overcome the crisis is not more energy, but less. More energy would mean more pollution, more chemical poisoning, more social injustice, more cancer, more crime. Once these facts are perceived, the use of nuclear power as an energy source is sheer folly. It surpasses the ecological impact of coal by several orders of magnitude, threatening to poison our natural environment for thousands of years and even to extinguish the entire human species. Nuclear power represents the most extreme case of a technology that has got out of hand, propelled by an obsession with self-assertion and control that has reached pathological levels. Nuclear power itself has two linked meanings: power as a source of energy and power as the possession of control over others, inseparably connected in the nuclear case, both representing the greatest threat to our survival and well-being. The arms race and the nuclear threat. The Defense Department and the military industry have created a series of public hysterias about national defense to obtain increases in military spending, perpetuating the myth of an arms race in which the Russians are ahead. In reality, as Daniel Ellsberg showed, the United States led the Soviet Union throughout the 1950s and early 1960s, and American plans contemplated first use of nuclear weapons, with several presidents making nuclear threats kept secret from the public. Today, there is a balance of power, but the Pentagon again distorts the truth, wanting to regain its former superiority. Officially, policy is deterrence, but a closer look shows the current plans are not aimed at deterrence at all. Their purpose is a nuclear first strike. One Poseidon submarine carries enough warheads to destroy every large and medium-sized city in the Soviet Union. 20 to 30 are always at sea, so the United States at all times can destroy every Russian city 20 to 30 times over. The new high-precision weapons, cruise and MX missiles, are designed to destroy an enemy missile in its silo before it is fired. They are clearly weapons of aggression, and Robert Aldridge, who quit Lockheed, concluded that the United States is rapidly approaching a first strike capability, while the Soviet Union struggles for second best. In 1960 to 61, there were American plans for a first strike in case of any direct confrontation with the Russians. If such planning continues, the local conflict could trigger an all-out nuclear war in which 500 million people die after the first exchange, almost no living thing surviving. mutually assured destruction mad. The psychological background to this nuclear madness is an overemphasis on self-assertion, control, power, and an obsession with winning, the typical traits of patriarchal culture. Nuclear weapons are the most tragic case of people holding onto an old paradigm that has long lost its usefulness. American nuclear technology, and with it the raw materials to make nuclear bombs, is being exported all over the world. Only 10 to 20 pounds of plutonium are required to make a bomb, and each reactor produces 400 to 500 pounds annually. Through plutonium, reactor technology and weapons technology have become inseparably linked. Nuclear technology is promoted in the Third World not to satisfy energy needs, but those of multinational corporations. Politicians welcome it because it gives them a chance to build nuclear weapons. Even without a nuclear holocaust, the environmental impact of nuclear power far exceeds all other hazards of our technology. Nuclear accidents have threatened hundreds of thousands of people, and radioactive substances continually poison our environment, with cancer developing after 10 to 40 years and genetic diseases appearing in future generations. There is no safe level of radiation. Even the smallest amounts can produce mutations and diseases. The nuclear reaction, fission, releases heat that boils water to drive a turbine. A nuclear reactor is a highly sophisticated, expensive, and extremely dangerous device for boiling water. Accidents are unavoidable. The worst possibility, a meltdown, would scatter deadly radioactive materials like an atomic bomb. Many nuclear accidents have already happened. 3 Mile Island, and the 1961 H-bomb dropped over Goldsboro, North Carolina, whose one surviving safety device protected us from an explosion more powerful than the combined explosions of all the wars in human history. The disposal of nuclear waste remains unsolved. Each reactor produces tons of radioactive waste that remains toxic for thousands of years, and plutonium remains poisonous for at least 500,000 years, more than 100 times longer than all of recorded history. What moral right do we have to leave such a deadly legacy? No human technology can create safe containers for such a time span. Nuclear waste keeps piling up, with 152 million gallons of high-level waste projected by the year 2000. Plutonium, named after Pluto, the god of the underworld, is the most deadly of all waste products. Less than 1/millionth of a gram is carcinogenic, and 1 pound, uniformly distributed, could induce lung cancer in every person on Earth. It must be isolated virtually forever, since even the tiniest amounts contaminate the environment for eons. If the American nuclear industry expanded according to projections and contained its plutonium with 99.99% perfection, something of a miracle, it would still be responsible for 500,000 fatal lung cancers per year for 50 years. Nuclear power also creates the problem of decommissioning reactors, fast breeder reactors, the threat of nuclear terrorism and a totalitarian plutonium economy, and disastrous economic consequences. It is unsafe, uneconomical, irresponsible, and immoral, totally unacceptable. Why is it still promoted so heavily? Because nuclear power leads to the highest concentration of political and economic power in the hands of a small elite. It requires highly centralized institutions, lends itself to secrecy and police power, and its protagonists have invested billions of dollars. As Ralph Nader says, nuclear power has become America's technological Vietnam, the consumer society, and the drug industry. The health hazards created by the economic system are caused not only by production, but by the consumption of goods produced and heavily advertised to sustain expansion. To increase profits in a saturated market, manufacturers lower the quality of products and spend vast sums conditioning consumer opinion through advertising. The food industry is an outstanding example. Nutrition is one of the most important influences on our health, but doctors are notoriously ignorant about diet. A healthy diet should be well-balanced, low in animal protein, high in natural carbohydrates, foods that are natural, whole, and poison-free. Yet food manufacturers add preservatives, replace organic food with synthetic products, add artificial flavoring and coloring, and advertise the result heavily, together with alcohol and cigarettes. Over 70% of food advertising on weekdays is negatively related to the nation's health needs. The problems of an unhealthy diet are compounded by the excessive use of drugs. Aspirin is consumed at 225 tablets per person per year, and the biggest problem is the soaring use of prescription drugs, especially psychoactive drugs. The pharmaceutical industry is among the largest, with profit rates outranking other manufacturers. Its outstanding characteristic is the differentiation of basically similar products, research and marketing devoted to making drugs seem distinctive, inundating the market with thousands of redundant medications, many marginally effective and all with side effects. The influence of drug manufacturers on medical care extends beyond advertising. The Pharmaceutical Manufacturers Association has close ties with the American Medical Association, whose journals receive about half their income from drug advertising. The physician's desk reference, consulted by 75% of doctors, is prepared and paid for by the drug companies. The industry's detail men saturate doctors with sales talk, samples, prizes, and educational seminars in the Bahamas, spending an average of $4,000 per physician on promotion, 65% more than on research. The AMA neglected to inform physicians about the adverse effects of antibiotics, the drugs most abused and most dangerous, while providing unlimited advertising space for them. Norlutin, a hormone found dangerous in pregnancy, was advertised for months after the JAMA reported its risks. Pharmaceutical advertising presents stressful life situations as diseases amenable to drug treatment, and its treatment of women is blatantly sexist. Women take over 60% of all psychoactive drugs and over 70% of antidepressants, and advertisements advise doctors to tranquilize women unhappy with their roles in society. Chemical agriculture and the Green Revolution. The influence of the pharmaceutical industry on medicine has a parallel in that of the petrochemical industry on agriculture. Like the human organism, the soil is a living system that must remain in dynamic balance. When the balance is disturbed, there is pathological growth, weeds and pests in the fields, bacteria and cancer cells in the body. A fertile soil is a living soil, a complex ecosystem in which carbon and nitrogen move in cycles from plants to animals to soil bacteria and back. Bacteria fix nitrogen. Earthworms loosen the soil. Traditional farming preserved these cycles through crop rotation, manure, and respect for life. About 3 decades ago, farmers switched to synthetic products, opening vast markets for the oil companies. The new era was hailed as the Green Revolution, but it helped neither the farmers nor the land nor the starving millions. Only the petrochemical corporations. The industry persuaded farmers to plant single-crop monocultures controlled by chemicals, with great losses of genetic variety and high risks of destruction by a single pest. Farming became mechanized and energy-intensive, with the energy used to produce an acre of corn increasing fourfold, even as labor fell by 2/3. 3 million American farms have been eliminated since 1945. Farmers lost their freedom and creativity, growing what the market dictates rather than what the land indicates. Farming is almost totally controlled by the petrochemical industry, whose sales force supplies the information. As Commoner said, convincing the farmer to give up the free solar energy that drives the natural cycles and buy the needed energy as fertilizer and fuel. The long-term effects of excessive chemotherapy in agriculture have been disastrous. The balance of the soil is disrupted. Organic matter diminishes. The soil becomes dead and dry, susceptible to wind and water erosion. Half of Iowa's topsoil has washed away in 25 years. Chemical fertilizers damage the bacteria of nitrogen fixation, so crops become addicted to synthetic chemicals that leach into groundwater. Monocropping and chemical fertilizers produce enormous increases in pests, which farmers fight with ever larger doses of pesticides, and the pests become immune. Since World War II, crop losses due to insects have almost doubled. 60% of the costs of food are now costs of petroleum. As Wes Jackson puts it, we have literally moved our agricultural base from soil to oil. The hazards for human health are no less severe. Toxic chemicals seep through the soil, contaminate the water table, and show up in food. Half the pesticides on the market are mixed with petroleum distillates that may destroy the immune system. The oil companies sell the most dangerous chemicals in the third world, where legislation is less strict and the toxic residues come back on imported fruits and vegetables. The principal justification for the Green Revolution, that it would feed the world's hungry, is false. As Francis Moore Lapp and Joseph Collins have shown, the problem of world hunger is not technical, but social and political. Scarcity of food is a myth. The world produces enough to feed 8 billion people, and no country lacks the resources to feed itself. Inequality is the main stumbling block. Agricultural modernization is highly profitable for a small elite and drives millions off the land. And once established, large landholders switch to profitable crops for export while the local population starves. In Central America, at least half the fertile land grows cash crops, while up to 70% of children are undernourished. World hunger can be overcome only by transforming social relations and redistributing control over agricultural resources. A food-first policy, planting industrial crops only after people's basic needs are met, has eliminated hunger in countries embracing it. Our own food security is threatened not by the hungry masses, but by the food and agricultural corporations creating a single world agricultural system in which they control all stages of production, a global supermarket in which the world's poor compete with the affluent and can never feed themselves. Agribusiness also ruins the soil, perpetuates social injustice, and seriously threatens global ecological balance. An enterprise that was originally nourishing and life-sustaining has become a major hazard. The health industry and the rising culture. The more we study the social problems of our time, the more we realize that the mechanistic worldview has generated technologies and lifestyles that are profoundly unhealthy, aggravated by a healthcare system unable to deal with them because of its adherence to the same paradigm that perpetuates the causes of ill health. The shortcomings of the healthcare system result from the interplay of two tendencies: the narrow biomedical framework denying the relevance of non-biological aspects to illness, and the pursuit of economic and institutional growth by the health industry, dominated by the same financial and corporate forces that shape the rest of the economy. The aim of the health industry has been to turn healthcare into a commodity sold like any other, favoring a highly centralized, technology-intensive approach that is profitable for the industry, but expensive and unhealthy for patients. But the problems of rising costs, diminishing returns, and the evidence that environmental, occupational, and social factors are the primary causes of ill health will inevitably force change. And the change has already begun. The holistic health movement, active within and outside the medical system, is supported by environmental groups, anti-nuclear organizations, consumer groups, and social liberation movements, all subscribing to a holistic and ecological view of life and rejecting the value system that dominates our culture. The new rising culture shares a vision of reality that will eventually emerge as a new paradigm, destined to eclipse the Cartesian worldview in our society. The toxic time bombs, the thousands of chemical dump sites created by profitable, unrecycled production, among the most serious environmental threats of the 1980s. Acid rain, the invisible product of coal combustion, sulfur and nitrogen oxides turn to acids, killing lakes and forests, one of the most insidious forms of air pollution. Nuclear power's double meaning: power as energy and power as control, inseparably linked, both the greatest threat to our survival. Mutually assured destruction, mad the Pentagon's first strike planning. The human species as the intended casualty of a 30-minute war. The plutonium economy, nuclear power as the highest concentration of political and economic power in a small elite, requiring secrecy and police power. The Green Revolution, chemical agriculture that helped neither farmers nor land nor the hungry, only the petrochemical corporations, turning soil into oil. The global supermarket, worldwide corporate control of food production, in which the poor compete with the affluent and can never feed themselves. The medical industrial complex, the health industry's transformation of care into a commodity, dominated by the same corporate forces as the rest of the economy. Quote, "We have literally moved our agricultural base from soil to oil." Wes Jackson, as quoted by Capra. Quote, In the third world, on the whole, there is more food and less to eat. Francis Moore Lapp and Joseph Collins, as quoted by Capra, quote, "Just as federal defense appropriations subsidize the military-industrial complex, national health insurance will subsidize the medical-industrial complex." From a study of healthcare, as quoted by Capra. 9. The system's view of life. The system's biology. The new vision of reality is based on awareness of the essential interrelatedness and interdependence of all phenomena: physical, biological, psychological, social, and cultural. It transcends current disciplinary and conceptual boundaries, and in this situation, a bootstrap approach, similar to the one contemporary physics has developed, may be most fruitful, gradually formulating a network of interlocking concepts and models while developing the corresponding social organizations, none of them more fundamental than the others, all mutually consistent. Since the concept of health depends crucially on one's view of living organisms and their relation to the environment, the presentation of the new paradigm begins with the nature of living organisms. Most of contemporary biology and medicine adheres to a mechanistic view, trying to reduce the functioning of organisms to cellular and molecular mechanisms. This view is justified to some extent. Living organisms do act in part like machines, having developed machine-like parts because machine-like functioning was advantageous in their evolution. But this does not mean they are machines. Biological mechanisms are special cases of much broader principles of organization, and no operation of any organism consists entirely of such mechanisms. A fuller understanding of life will be achieved only by developing a systems biology, a biology that sees an organism as a living system rather than a machine. The systems view looks at the world in terms of relationships and integration. Systems are integrated wholes whose properties cannot be reduced to those of smaller units. Instead of concentrating on basic building blocks, the systems approach emphasizes basic principles of organization. Examples abound. Every organism, from bacterium to human, is an integrated whole. So are cells, tissues, organs, social systems like the anthill and the human family, and ecosystems. What is preserved in a wilderness area is not individual trees, but the complex web of relationships between them. Systemic properties are destroyed when a system is dissected into isolated elements. The nature of the whole is always different from the mere sum of its parts. Systems are also intrinsically dynamic. Their forms are flexible, yet stable manifestations of underlying processes. As Paul Weiss put it, living form is an overt indicator of the dynamics of the underlying formative processes. This description sounds quite similar to modern physics. And indeed, the new physics, especially its bootstrap approach, is very close to general systems theory. Systems thinking is process thinking. Form becomes associated with process, interrelation with interaction. The emergence of organic patterns is fundamentally different from the stacking of building blocks. Nevertheless, machine-like operations occur throughout the living world, and the reductionist description can be useful. It is dangerous only when taken to be the complete explanation. Reductionism and holism, analysis and synthesis, are complementary approaches that, in proper balance, give a deeper knowledge of life. Organism and machine, self-organization. Examining the essential differences between an organism and a machine, the clockwork of Descartes and Newton, not the modern cybernetic machine. The first obvious difference is that machines are constructed, whereas organisms grow. The understanding of organisms must therefore be process-oriented. Cells, like all living systems, have to be understood in terms of processes reflecting the system's dynamic organization, whereas the activities of a machine are determined by its structure. An organism's organic structure is determined by processes. Organisms show a high degree of internal flexibility and plasticity. No two organisms have identical parts, and the relationships between parts are not rigidly determined. This flexibility enables organisms to adapt to new circumstances. Machines function according to linear chains of cause and effect, with a single cause for any breakdown identifiable. Organisms are guided by cyclical patterns of information flow known as feedback loops, And when such a system breaks down, the breakdown is usually caused by multiple factors that amplify each other. This nonlinear interconnectedness indicates that attempts to associate diseases with single causes are highly problematic and shows the fallacy of genetic determinism. Genes are integral parts of an ordered whole, not cogs and wheels dictating the organism's functioning. The internal plasticity and flexibility of living systems gives rise to the principle of self-organization. A living organism is a self-organizing system whose order and structure and function is established by the system itself, not imposed by the environment. Self-organizing systems exhibit a degree of autonomy. They establish their size according to internal principles, independent of environmental influences, though they interact with the environment continually. The two principal dynamic phenomena of self-organization are self-renewal, the ability to renew and recycle components while maintaining the integrity of the overall structure, and self-transcendence, the ability to reach out creatively beyond boundaries in learning, development, and evolution. The relative autonomy of self-organizing systems sheds new light on free will. Both determinism and freedom are relative concepts. To the extent a system is autonomous, it is free, and this relative autonomy culminates in human beings, a view consistent with the mystical traditions that urge us to see ourselves as inseparable parts of the cosmos. To maintain self-organization, living organisms must remain in a special state. Unlike a clockwork, which proceeds from order to disorder toward equilibrium, organisms are open systems that maintain a continuous exchange of energy and matter with the environment. Metabolism, allowing them to operate far from equilibrium, which is absolutely necessary for self-organization. Yet their stability is utterly dynamic, consisting in maintaining the same overall structure in spite of ongoing changes. We replace all our cells within a few years, yet recognize our friends after long separation. The phenomenon of self-organization is not limited to living matter. Progenes, dissipative structures, chemical systems that maintain structure by breaking down other structures, display most of the phenomena of life, self-renewal, adaptation, evolution, representing a link between animate and inanimate matter. Self-renewal is an essential aspect of self-organizing systems. An organism is primarily engaged in renewing itself. The pancreas replaces most of its cells every 24 hours, the stomach lining every 3 days, 98% of the brain's protein within a month, and this self-maintenance persists under a variety of circumstances, repairing itself through healing and regeneration. No complex organism can function indefinitely. To survive, species developed super repair, replacing the whole organism. Reproduction. Fluctuations play a central role. All variables oscillate between limits in a state known as homeostasis, a dynamic, transactional balance with great flexibility. Negative feedback reduces deviations, while positive feedback amplifies them, playing a crucial role in development, learning, and evolution. Higher organisms are capable of 3 kinds of adaptation. The quickly reversible stress reaction, somatic change, which internalizes stress and whose accumulation may lead to illness, and genotypic change in evolution, which provides more flexibility. The 3 modes are characterized by increasing flexibility and decreasing reversibility, restoring the flexibility lost under environmental stress. The Darwinian concepts express only one of 2 complementary views of evolution. The other is the creative development of new structures without environmental pressure, a manifestation of the potential for self-transcendence inherent in all living organisms. Organism and environment, ecosystems, and symbiosis. As the notion of an independent physical entity has become problematic in subatomic physics, so has that of an independent organism in biology. Living organisms keep themselves alive through intense transactions with their environment, which itself consists partially of organisms. The whole biosphere is a dynamic and highly integrated web of living and non-living forms. Most organisms are not only embedded in ecosystems, but are complex ecosystems themselves, containing smaller organisms that integrate harmoniously into the whole. The mitochondria and chloroplasts within our cells are independent, self-replicating organisms living in symbiosis, And, as Lewis Thomas observed, we do not have solitary beings. Every creature is, in some sense, connected to and dependent on the rest. The boundaries between organism and environment are often difficult to ascertain. Viruses exist on the borderline between living and non-living matter, chemical messages that take over the cell's replication machinery. Corals build massive reefs that become ecosystems supporting hundreds of species. Social insects form colonies that resemble a single organism with collective intelligence. Symbiosis is so widespread it has to be considered a central aspect of life, involving animals, plants, and microorganisms in almost every combination. Larger networks of organisms form ecosystems, self-organizing and self-regulating systems, in which particular populations undergo periodic fluctuations. Because of the nonlinear nature of their interconnections, any serious disturbance is likely to spread throughout the system. In a balanced ecosystem, every species has the potential for exponential growth kept in check by interactions. When a system is disturbed, exponential runaways appear. Plants turn into weeds, animals into pests, and explosive growth of this kind occurs also in single organisms. Cancers are dramatic examples of pathological growth. Detailed study has shown that most relationships between living organisms are essentially cooperative, symbiotic in various degrees. Competition usually takes place within a wider context of cooperation. This insight is in sharp contrast to the social Darwinists, who saw life exclusively in terms of struggle and destruction, a view that has no scientific justification and has helped create a philosophy legitimating exploitation. Excessive aggression and destructive behavior are predominant only in the human species and have to be dealt with in terms of cultural values rather than being explained pseudoscientifically as natural. Stratified order, death, and Gaia. The tendency of living systems to form multi-leveled structures, each level consisting of systems that are wholes in regard to their parts and parts with respect to larger wholes, is a basic principle of self-organization, all-pervasive throughout nature. The human organism contains organ systems made of organs, made of tissues, made of cells. Every subsystem is a holon, in Kessler's term, manifesting both the independent properties of wholes and the dependent properties of parts. Stratified systems evolve more rapidly and survive better, decomposing into subsystems without being completely destroyed. The term hierarchy is misleading for this pattern. A hierarchy is a rigid system of domination in which orders are transmitted from the top down, its symbol the pyramid. Most living systems exhibit multi-leveled patterns of organization with nonlinear pathways along which signals propagate ascending and descending, which is why I have turned the pyramid into a tree, a more appropriate symbol for the ecological nature of stratification, in which power flows in both directions and all levels. Interact in interdependent harmony. The important aspect of stratified order is not the transfer of control, but the organization of complexity. Any level is really the level of the observer's attention. The observed patterns of matter are reflections of patterns of mind. The concept of stratified order also provides the proper perspective on death. Self-renewal is an essential aspect of living systems, but the structures continually being replaced are themselves living organisms. From their point of view, the self-renewal of the larger system is their own cycle of birth and death. Birth and death appear as central aspects of self-organization, the very essence of life. Everything around us is in the process of dying, but for every organism that dies, another is born. Death is not the opposite of life, but an essential aspect of it. Not all organisms die. Simple one-celled organisms reproduce by division and simply live on in their progeny. This kind of life without death was the only kind for the first two-thirds of evolutionary history. About 1 billion years ago, life had to invent sex and death, as Leonard Schlein put it. Without sex, there could be no variety. Without death, no individuality. Sexual reproduction, generating enormous genetic variety, made evolution proceed thousands of times faster. At the largest level, detailed studies of how the biosphere regulates the chemical composition of the air and the temperature of the Earth have led James Lovelock and Lynn Margulis to suggest that the planet as a whole is a single living organism, the Gaia hypothesis, named after the Greek goddess of the Earth. The planet persists in a remarkable state of chemical and thermodynamic non-equilibrium, regulating the planetary environment so that optimal conditions for life are maintained. The climate has never been totally unfavorable for life in 4 billion years, despite a 30% increase in solar radiation. The Earth's surface temperature remained fairly constant, much as a human organism maintains its body temperature. The Earth, then, is a living system. Its properties cannot be predicted from the sum of its parts. Its pathways of communication are highly complex and nonlinear. Its form has evolved over billions of years. These observations were made within a scientific context, but they go far beyond science. They reflect a profound ecological awareness that is ultimately spiritual. Evolution as self-transcendence. The system's view of evolution focuses on the dynamics of self-transcendence, whose central characteristic is not adaptation but creativity. If adaptation alone were the core of evolution, it would be hard to explain why living forms ever evolved beyond the blue-green algae, perfectly adapted and unsurpassed in reproductive capacity for billions of years. The basic dynamics begins with a system in homeostasis. When disturbed, negative feedback tends to reduce the deviation. But deviations may also be reinforced through positive feedback until fluctuations drive the system over an instability into an entirely new structure. The stability of living systems is never absolute. Any system is always ready to transform itself, always ready to evolve. The classical theory sees evolution as moving toward equilibrium. The system's view sees it operating far from equilibrium, unfolding through an interplay of adaptation and creation, and taking into account that the environment is itself a living system. The focus shifts to the coevolution of organism plus environment. Chance and necessity come into play simultaneously as complementary principles. The system's reaching a critical point may occur at random, but once reached, the system is forced to evolve into a new structure, and which of the possible new structures is chosen is impossible to predict. There is true freedom of choice, a multi-forked graph with free decisions at each branching point. Evolution is open and indeterminate, without goal or purpose, yet with a recognizable pattern, an unfolding of order and complexity that can be seen as a kind of learning process. The unit of survival is not an entity at all, but a pattern of organization adopted by an organism in its interactions with its environment. The organism in its environment. An organism that thinks only of its own survival will invariably destroy its environment and thus destroy itself. In the history of life, two steps enormously accelerated evolution: sexual reproduction, which introduced extraordinary genetic variety, and the emergence of consciousness, which made it possible to replace genetic mechanisms with more efficient social mechanisms based on conceptual thought and symbolic language. The earliest life forms, prokaryotes, produced oxygen through photosynthesis for 2 billion years, setting the stage for eukaryotes, which, according to Lynn Margulis, originated in a symbiosis between several prokaryotes that continued to live on as organelles, managing the energy household of the planetary Gaia system for 4 billion years. Mind, consciousness, and the cosmic web. To extend the system's view to social and cultural evolution, we deal with mind and consciousness. Gregory Bateson proposed to define mind as a systems phenomenon characteristic of living organisms, societies, and ecosystems, satisfying criteria closely related to those of self-organizing systems. Mind is the essence of being alive. From a systems point of view, life is not a substance or force, and mind is not an entity interacting with matter. Both are manifestations of the same set of systemic properties, the dynamics of self-organization. Mind and matter no longer appear to belong to two fundamentally separate categories, as Descartes believed, but represent different aspects of the same universal process. I reserve the term mind for organisms of high complexity and use mentation for the dynamics of self-organization at lower levels. A metafunction that at lower levels looks like behavior, but at higher levels takes on the distinctive non-spatial, non-temporal quality we associate with mind. Mind is immanent not only in the body, but also in the pathways and messages outside it. There are larger manifestations of mind of which our individual minds are only subsystems. This recognition has radical implications. If we see the environment as mindless, we will tend to exploit it. Our attitudes will be very different when we realize that the environment is not only alive, but also mindful like ourselves. Individual human minds are embedded in the larger minds of social and ecological systems, integrated into the planetary mental system, the mind of Gaia, which in turn participates in a cosmic mind, which may be associated with the traditional idea of God, not the creator, but the mind of the universe, the self-organizing dynamics of the entire cosmos. The human brain is a living system par excellence. You can never wear it out. The more you use it, the more powerful it becomes. The nervous systems of higher animals are so complex that understanding their functioning in purely reductionistic terms seems hopeless. Two complementary approaches are needed, a reductionist one for the detail mechanisms and a holistic one for their integration into the whole. This complementarity is reflected in the structure of the brain. The left hemisphere is specialized in analytic, linear thinking, the right in a holistic mode appropriate for synthesis. A discovery that contradicts our culture's Cartesian bias, expressed in the old designation of the left as the major hemisphere, and in the deep-rooted preference for the right side, the one controlled by the left brain. In so many languages, right meaning correct and just sinister meaning left and threatening, one wonders whether this may be related to the patriarchal value system. Human beings possess consciousness, self-awareness, and create an inner world that mirrors the outer reality, with an existence of its own. The patterns we perceive around us are based in a fundamental way on the patterns within. The modification of sensory perception by past experiences begins at the very outset, at the gates of perception, so that all perception is to some extent extrasensory. The inner and outer worlds are always interlinked and evolve together. There are two opposing views of consciousness. The Western scientific view, that consciousness is a property of complex material patterns, and a mystical view, that consciousness is the primary reality and ground of all being, pure consciousness associated with the divine. The system's view of mind seems perfectly consistent with both, providing the ideal framework for unifying them. Consciousness is a manifestation of living systems of a certain complexity, and the material structures of these systems are expressions of underlying processes that represent the system's self-organization, hence its mind. Extending this to the universe as a whole, all its structures are manifestations of the universe's self-organizing dynamics, the cosmic mind, which is almost a mystical view. Human evolution progresses through an interplay of inner and outer worlds, nature and culture. Humankind emerged through the very process of creating culture and needs it for survival. The anatomical evolution of human nature was completed some 50,000 years ago, and the species shifted from genetic to social evolution. But we still carry biological equipment from earlier stages. The brain, according to Paul MacLean, consists of three parts. The brain stem concerned with instinctive behavior, the limbic system involved with emotion, and the neocortex facilitating abstract thought, of which MacLean says, when a psychiatrist bids the patient to lie on the couch, he is asking him to stretch out alongside a horse and a crocodile. By developing abstract thinking so rapidly, we seem to have lost the ability to ritualize social conflicts. The wisdom of the animal world, where fights end with the loser unharmed. We have become the only creatures who often kill their own kind. The evolution of consciousness has given us the burning of witches, the Holocaust, and Hiroshima, but also the potential to live peacefully and in harmony with the natural world. Our evolution continues to offer us freedom of choice. Rhythm, the hologram, and the spirit. In the future elaboration of the new holistic worldview, the notion of rhythm is likely to play a fundamental role. Process and stability are compatible only if processes form rhythmic patterns. Fluctuations, oscillations, vibrations, waves, ordered structures arise from rhythmic patterns. Rhythmic patterns are manifest at all levels. Atoms are patterns of probability waves. Molecules are vibrating structures. Civilizations rise and fall in evolutionary cycles. Rhythmic patterns also allow individuals to express their distinctive personalities. Personal identity may be, essentially, an identity of rhythm, an inner pulse, the essence of personal identity. The role of rhythm extends to perception and communication. The reality around us is an ongoing rhythmic dance, and our senses translate its vibrations into frequency patterns. Carl Pribram has developed a holographic model of the brain in which visual memory is organized like a hologram, the whole encoded in each part. A metaphor relating to Chu's idea that every particle involves all others, and to Bohm's notion of the implicate order, suggesting the holonomy, the whole contained in each part, may be a universal property of nature, expressed also in a mystical vision of all in each and each in all. Human communication takes place through the synchronization of individual rhythms. Every conversation is a subtle, largely unseen dance. Disharmony arises when rhythms are out of synchrony. At rare moments, we feel in synchrony with the whole universe, a perfect shot, a fulfilling sexual experience, deep meditation, high spiritual experiences in which every form of separateness is transcended. The system's view of life is spiritual in its deepest essence, consistent with the ideas of mystical traditions. Two basic themes emerge from the study of living matter and are emphasized in the teachings of mystics: the universal interconnectedness of all phenomena and the intrinsically dynamic nature of reality. The concept of stratified order plays a prominent role in many traditions, with multiple levels of reality and levels of mind as manifestations of cosmic consciousness. The concepts of process, change, and fluctuation are emphasized in Taoism, with the idea of fluctuations as the basis of order, introduced into modern science by Prigogine, is a major theme. Birth and death are seen as stages of endless cycles. Among Western mystics, the one whose thought comes closest to the new system's biology is Pierre Teilhard de Chardin, whose law of complexity consciousness states that evolution proceeds toward increasing complexity accompanied by a rise of consciousness, culminating in human spirituality. He coined the term noosphere for the web of ideas covering the planet, and his concept of God, if liberated from patriarchal connotations, may well be the one that comes closest to the views of modern science. Teilhard has often been attacked by scientists unable to look beyond the reductionist Cartesian framework. With the new system's approach, his ideas will appear in a new light, contributing to the recognition of a harmony between the views of scientists and mystics. Systems biology, biology that sees an organism as a living system rather than a machine, integrated wholes whose properties cannot be reduced to those of smaller units. Self-organization, the principle by which living systems establish their own order and structure and function. Autonomous, self-renewing, self-transcending. Dissipative structures, Prigogine's chemical systems that maintain structure by breaking down other structures. The link between animate and inanimate matter. Feedback loops, the cyclical patterns of information flow guiding organisms, in contrast to the linear chains of cause and effect of machines. The system's tree, the multileveled, non-hierarchical pattern of stratification in living systems, replacing the pyramid of domination. Gaia, the planet as a living, self-regulating organism, a hypothesis and an ancient myth revived. Coevolution, evolution as the mutual adaptation of organism plus environment, unfolding through adaptation and creation. Mentation, the dynamics of self-organization at all levels, behavior at lower levels, mind at higher ones. The environment is not only alive but mindful. Quote, living form must be regarded as essentially an overt indicator of, or clue to, dynamics of the underlying formative processes. Paul Weiss, as quoted by Capra, quote, we do not have solitary beings. Every creature is, in some sense, connected to and dependent on the rest. Lewis Thomas, as quoted by Capra, Quote, "Mind is the essence of being alive." Gregory Bateson, as quoted by Capra. 10. Wholeness and health, shamanism, and the traditional medical systems. To develop a holistic approach to health consistent with the new physics and the system's view, we do not need to break completely fresh ground, but can learn from medical models existing in other cultures. Modern scientific thought is leading to a view of reality that comes very close to the views of mystics and of many traditional cultures, in which knowledge of the human mind and body and the practice of healing are integral parts of natural philosophy and spiritual discipline. Comparisons of medical systems must be made carefully, since any system of healthcare is a product of its history and cultural context. But cross-cultural studies broaden our perspective and help us see current ideas about health in a new light. Throughout the ages, cultures have oscillated between reductionism and holism in their medical practices, and when their approaches were fragmented, that reductionism was often very different from the one that dominates our current scientific medicine. So comparative studies may be very instructive. In non-literate cultures, the origin of illness and the process of healing have been associated with forces of the spirit world, and among the resulting practices, shamanism offers a number of parallels to modern psychotherapies. A shaman is a man or woman able, at will, to enter a non-ordinary state of consciousness to make contact with the spirit world on behalf of the community. In non-literate societies, the religious and political leader and the doctor, a powerful charismatic figure. The outstanding characteristic of the shamanistic conception of illness is the belief that human beings are integral parts of an ordered system, and that all illness is the consequence of disharmony with the cosmic order. Therapies emphasize the restoration of harmony and balance within nature, human relationships, and the spirit world. Whereas Western medicine focuses on the biological mechanisms producing illness, the principal concern of shamanism is the socio-cultural context in which the illness occurs. A shaman is likely to mention competition, jealousy, greed, or wrongdoing by a member of the patient's family. These systems are often not holistic in the Western sense. The search for a cause may matter more than therapy, and diagnosis can be a social event in which the patient is merely a symbol of a conflict within the society. Shamanistic therapies follow a psychosomatic approach, applying psychological techniques to physical illness. As Levi Strauss described, the shaman cures a sick woman by calling upon the myths of her culture and helping her integrate her pain into a whole where everything is meaningful. Once she understands her condition in relation to this broader context, the healing takes place. Shamans used group sharing, psychodrama, dream analysis, hypnosis, guided imagery, and psychedelic therapy centuries before they were rediscovered. But where modern psychotherapists help patients construct an individual myth, shamans provide a social myth, working with the collective unconscious shared by the community. The universal shamanistic view of human beings as integral parts of an ordered system is completely consistent with a modern system's view, and the conception of illness as disharmony and imbalance is likely to play a central role in the new holistic approach. Hippocratic medicine and the Chinese system. Similar insights may be gained from the high-tradition medical systems developed by the major civilizations and passed on in written texts. Two ancient systems, one Western, one Eastern, illustrate their wisdom. The Hippocratic tradition at the roots of Western medicine and classical Chinese medicine, the basis of most East Asian traditions. Greek healing was originally a spiritual phenomenon associated with deities. Hygeia, the goddess of health, concerned with the maintenance of health through wise living, and her sister Panacea, skilled in remedies, prevention, and therapy, aspects as valid today as in ancient Greece, though the search for a panacea has become a dominant theme in modern biomedical science, which loses the balance between them. The Hippocratic tradition emerged from the lay Asclepiads, culminating in the physician Hippocrates. At its core is the conviction that illnesses are not caused by demons, but are natural phenomena that can be studied scientifically and influenced by therapy and wise management of life. Airs, Waters, and Places is a treatise on human ecology, showing how well-being is influenced by environmental factors, the quality of air, water, and food, living habits, The relevance of environmental forces has never been formulated with greater breadth, as Dubois says. Health requires a state of balance among environmental influences, ways of life, and the components of human nature, described in terms of humors and passions to be in equilibrium, a doctrine of chemical and hormonal balance, and of the interdependence of mind and body. Hippocrates recognized the healing forces inherent in organisms, nature's healing power. The role of the physician was to assist these forces by creating favorable conditions. The original meaning of therapy, from the Greek therapeuin, to attend. Modern medicine is but a series of commentaries on the Hippocratic writings. Classical Chinese medicine, shaped by Taoism and Confucianism and formalized in the Han period in the Nei Qing, the classic of internal medicine, centers on the concepts of yin and yang. The human organism is a microcosm of the universe, which is in a state of dynamic balance, with all components oscillating between the two archetypal poles. The Chinese were not interested in causal relations, but in the synchronic patterning of things, which Needham called correlative thinking. Things behave in particular ways because of their position in the ever-moving cyclical universe. The healthy individual and society are integral parts of a great patterned order, and illness is disharmony at the individual or social level. The Chinese concept of an organ refers to a whole functional system. The idea of the lungs includes the entire respiratory tract, the nose, the skin, and associated secretions, obviously much closer to the modern system's approach than to the Cartesian model. The organism, like the cosmos, is in a state of continual, multiple, interdependent fluctuations described as the flow of qi, which represents the principle of flow as such, always cyclical. Imbalances occur when the qi does not circulate properly along the meridians, with their pressure points. Illness is not an intruding agent, but a pattern of causes leading to disharmony. The nature of all things is such that there is a natural tendency to return to dynamic balance, and the texts draw no sharp line between health and illness. They are aspects of the same process. The ideal doctor is a sage who treats each patient individually, recording the total state of mind and body and its relation to the environment. The individual is responsible for the maintenance of her own health, and the emphasis is on prevention. To administer medicines to diseases which have already developed is comparable to digging a well after one has become thirsty. Yet the Chinese system is holistic only in the narrower sense. The interdependence of organism and environment is acknowledged in diagnosis, but neglected in therapy, which concentrates on dietary counseling, herbal medicine, and acupuncture, with no psychotherapy. The influence of Confucianism, for which illness arose from inadequate adjustment to the social order, the only remedy being to change oneself to fit it. What we can learn from the East is the proper valuation of subjective knowledge. Since Galileo, Descartes, and Newton, we have been so obsessed with rational knowledge and quantification that we have become insecure in dealing with human values and experience. Medical schools screen out those with the greatest talents for practicing medicine intuitively. The system's view of health. The system's view of health is profoundly ecological, in harmony with the Hippocratic tradition and with many spiritual traditions. Systems thinking is process thinking, so the system's view sees health as an ongoing process, not a static state of perfect well-being. Since a person's condition always depends on the natural and social environment, there can be no absolute level of health independent of it, and it is often impossible to draw a sharp line between health and illness. Health is a multidimensional phenomenon involving interdependent physical, psychological, and social aspects. Physical disease may be balanced by a positive mental attitude and social support, while emotional problems or social isolation can make a person feel sick in spite of physical fitness. There are three interdependent levels of health: individual, social, and ecological. And what is unhealthy for the individual is generally also unhealthy for the society and the embedding ecosystem. To be healthy, a system needs to be flexible, to have a large number of options for interacting with its environment. Loss of flexibility means loss of health. Health is an experience of well-being resulting from a dynamic balance involving the physical and psychological aspects of the organism and its interactions with its environment. This concept acknowledges the healing forces inherent in every living organism, its innate tendency to re-establish balance through self-maintenance, as in the minor illnesses that cure themselves, or through self-transformation and self-transcendence, involving stages of crisis and transition and resulting in an entirely new state of balance. Periods of ill health are natural stages in the ongoing interaction between individual and environment, to be used to learn and to grow. The natural balance includes a balance between the self-assertive and integrative tendencies. To be healthy, an organism must preserve its autonomy while integrating itself harmoniously into larger systems. Illness is a consequence of imbalance and disharmony, often stemming from a lack of integration. From the perspective of rhythmic patterns, synchrony becomes an important measure of health. To be healthy means to be in synchrony with oneself, physically and mentally, and with the surrounding world. When a person is out of synchrony, illness is likely to occur. To describe an organism's imbalance, the concept of stress is extremely useful. Stress is an imbalance in response to environmental influences. Temporary stress is an essential aspect of life, but prolonged stress can be harmful and plays a significant role in the development of many illnesses. From a systems point of view, stress occurs when variables are pushed to their extreme values, inducing rigidity throughout the system. The physiological stress symptoms, tight throat, tense neck, shallow respiration, accelerated heart rate, are virtually identical in animals and humans, constituting the organism's preparation to fight or flee. When the fight or flight response is prolonged and the individual cannot take action, the continual imbalance generates symptoms that eventually lead to illness. This often results from our failure to integrate the responses of our bodies with our cultural habits and social rules. In an intense business meeting, we cannot win an argument by assaulting our opponent, yet old parts of our brain continue mobilizing the organism for inappropriate physical responses. A key element is that prolonged stress suppresses the immune system. The sources of stress overload are manifold. Personal traumas, the hazardous environment created by our social and economic system, and also positive events, since all events requiring rapid adaptation are highly stressful. Our culture has produced an accelerating rate of change, but has failed to teach us how to cope with stress. Recognition of the role of stress leads to the idea of illness as a problem solver. People often choose, consciously or unconsciously, to get sick as a way out. The illness may be physical or mental, or manifest as crime, drug abuse, accidents, suicides, appropriately called social illnesses. Curing the disease will not necessarily make the patient healthy. If the escape into a disease is blocked while the stressful situation persists, the person may merely shift to another mode. Illness, then, may carry a message. Ill health should be taken as an opportunity for introspection so that the original problem can be resolved, where psychological counseling and psychotherapy can play an important role. Psychosomatic medicine and self-healing. When the system's view of mind is adopted, it becomes obvious that any illness has mental aspects. Getting sick and healing are integral parts of an organism's self-organization. And since mind represents the dynamics of this self-organization, the processes of getting sick and healing are essentially mental phenomena. The intimate interplay of physical and mental processes has been recognized throughout the ages and culminated in the foundation of psychosomatic medicine. The term needs clarification. In conventional medicine, it referred to a disorder without a clearly diagnosed organic basis, regarded as imagined. The modern use derives from the recognition of a fundamental interdependence between mind and body at all stages of illness and health. Virtually all disorders are psychosomatic, involving the continual interplay of mind and body in their origin, development, and cure. Mental illnesses involve physical symptoms, and their origin depends on the individual's interactions with family and social groups. The role of the patient's personality is a crucial element in the generation of many illnesses. Prolonged stress seems to be channeled through a particular personality configuration to give rise to a specific disorder, as convincingly found for heart disease and tentatively for cancer, suggesting the unification of physical and psychological therapies. The The psychosomatic nature of illness implies the possibility of psychosomatic self-healing, supported by the discovery of biofeedback, which showed that a wide range of physical processes can be influenced by mental efforts. The first step is the patient's recognition that they have participated consciously or unconsciously in the origin of their illness, and hence will also be able to participate in the healing process. Participation and responsibility being partial and relative, like free will, not associated with absolute moral values. The purpose of recognizing our participation is not guilt, but change. An impressive proof of the healing power of positive expectations is the placebo effect. 35% of patients consistently experience satisfactory relief from placebos, which have produced dramatic recoveries from illnesses for which there are no medical cures, the only active ingredient being the power of the patient's positive expectations. The placebo, the psychosomatic, and the spontaneous remission all refer to the healing powers of the patient's mental attitude. The patient's will to get well is crucial in any therapy, and negative attitudes may produce an inverse placebo effect. Patients told they have 6 to 9 months to live will indeed not live longer, statements that act as a magic spell and should never be made. In a future holistic approach, it should be possible to acknowledge the individual's potential for self-healing directly, without the need for conceptual crutches. The model of illness that emerges is holistic and dynamic. Illness is a consequence of imbalance and disharmony, often stemming from lack of integration, which may generate symptoms of a physical, psychological, or social nature. Disease is the biological manifestation of illness, and the model distinguishes disease origins from disease processes. Excessive stress contributes to the origin of most diseases, manifesting itself in the initial imbalance and being channeled through a personality configuration to give rise to specific disorders, with illness often perceived as a way out of the stressful situation. The development of illness involves the continual interplay of physical and mental processes reinforcing each other through feedback loops. Periods of ill health involving minor symptoms are normal and natural, representing the organism's means of restoring balance by forcing a change of pace. Severe illnesses require a therapeutic approach dealing not only with the physical and psychological aspects, but also with changes in lifestyle and worldview. Guidelines for healthcare. The system's view of health implies guidelines for a new holistic approach. Healthcare will consist of restoring and maintaining the dynamic balance of individuals, families, and social groups. It cannot just be provided or delivered. It has to be practiced. It is important to consider the interdependence of individual health and that of the social and ecological systems in which we are embedded. Managing stress by pushing it around, from one family to another, from society to the ecosystem, whence it may come back 40 years later as at Love Canal, resolves nothing. A future system of healthcare will consist first and foremost of comprehensive preventive care. Individual healthcare is based on the recognition that health is determined above all by behavior, food, and the nature of the environment. We have the power and responsibility to keep our organism in balance by simple rules of behavior relating to sleep, food, exercise, and drugs. A grassroots movement promoting healthy living habits has already arisen. But individual responsibility is subject to severe constraints. Freedom to look after ourselves is curtailed by social and cultural conditioning, and many health problems arise from economic and political factors modifiable only by collective action. Individual responsibility must be accompanied by social responsibility, social health care, with two basic parts: health education, teaching people how their behavior and environment affect their health and how to cope with stress, fostering corporate responsibility, and health policies, legislation to prevent health hazards, healthcare taxes on those who generate them, social policies, improving education and employment, family planning services, nutritional policies, and legislation. Supporting organic farming. A careful study of these policies shows that any one of them ultimately requires a different social and economic system. The present system itself has become a fundamental threat to our health, and we shall not be able to maintain our health without profound changes in our value system and social organization. The restructuring will apply first of all to the healthcare system itself. The first step in therapy will be to make the patient aware of the nature and extent of her imbalance, putting her problems into the broad context from which they arose. The recognition of this context alone is highly therapeutic, relieving anxiety and giving hope, thus initiating self-healing. The main purpose of the first encounter between patient and practitioner will be to educate the patient about the meaning of the illness and the possibilities of changing the patterns that led to it. The original role of the doctor, from the Latin docere, to teach. The basic aim of any therapy will be to restore the patient's balance, since the model acknowledges the organism's innate tendency to heal itself. The therapist will intrude only minimally, keeping treatments as mild as possible. The healing will always be done by the mind/body system itself. Such an approach is multidimensional, requiring a multidisciplinary team effort. The members share a common holistic view and speak a common language. Nurses at the forefront of the holistic health movement will be best qualified to take on the responsibilities of general practitioners, keeping regular contacts with clients, detecting problems before serious symptoms develop, going out into the community. Doctors will act as specialists, while the nurse keeps the personal contact and integrates the treatments into a meaningful whole. Hospitals will be transformed into comfortable, therapeutic environments modeled after hotels rather than factories. Drugs will be used only in emergencies, healthcare liberated from the pharmaceutical industry. Medical education will be reorganized around a multidisciplinary study of human nature based on general systems theory, with more emphasis on the behavioral sciences and human ecology. Rasmussen thinks nothing short of revolution can restore educational balance and relevance. National health insurance must not be dominated by corporate interests, and licensing laws revised to give the public greater freedom of choice. Therapeutic models, energy medicine, and bodywork. The paradigm shift in healthcare will involve the formulation of new conceptual models, since there is no well-established system of therapies corresponding to the new view of illness. A bootstrap approach is appropriate. A mosaic of therapeutic models of limited scope, mutually consistent, the general practitioner finding which approach suits a particular patient. Numerous unorthodox approaches share a belief in patterns of subtle energies or life energies, seeing illness as resulting from changes in these patterns. When homeopaths speak of the vital force, or Reichian therapists of bioenergy, they come close to the Chinese concept of qi. The main purpose of these terminologies is to describe the patterns of flow and fluctuation in the organism. The founders of these traditions had a remarkable intuition for the nature of life, and their concepts are likely to be useful when reformulated in systems language. Life energy should not be taken as a substance, but as a metaphor for the dynamic patterns of self-organization, to be understood through the concepts of flow, fluctuation, vibration, rhythm, and resonance. Homeopathy, founded by Samuel Hahnemann at the end of the 18th century, became especially popular in the United States, where 15% of all doctors were homeopaths around 1900. Illness results from changes in an energy pattern or vital force characteristic of each individual. Homeopaths detect imbalances before serious disturbances by observing subtle symptoms: sensitivity to cold, desire for salt or sugar, sleeping habits, establishing a total pattern or gestalt that mirrors the personality of the patient. Therapy consists of matching the patient's pattern with a similar pattern characteristic of the remedy, whose energy pattern resonates with the patient's, inducing the healing process. The selection of the remedy is based on the law of similars, like cures like. The homeopathic interview is an intimate interaction. As Vithulka says, the prescriber becomes an intimate participant in the life of the patient. One is tempted to wonder whether the crucial resonance is not between the patient and the homeopath, with the remedy merely a crutch. Wilhelm Reich, a pioneer of the paradigm shift, extended Freud's libido into bioenergy, a fundamental energy permeating the organism whose dynamic characteristic is pulsation. He discovered that emotions give rise to muscular patterns blocking the flow of energy, the character armor, and developed bodywork to destroy it. His concept of orgone energy, a primordial cosmic substance, was the most controversial part of his thinking and the reason for his persecution. His ergonomic functionalism is in perfect agreement with the process thinking of systems theory, and if Reichian theory were reformulated in modern systems language, its relevance would become even clearer. The therapies that facilitate balance through physical methods are known collectively as bodywork. They are based on the belief that all our activities, thoughts, and feelings are reflected in the physical organism, manifesting themselves in posture, movements, and tensions. The body is a reflection of the psyche, and work on either one changes the other. Eastern techniques, such as yoga, tai chi, and aikido, approach consciousness from the physical level, with breath as the fundamental link between the conscious and unconscious levels of mind. Chiropractors realign dislocated vertebrae to eliminate obstructions in the nervous flow. The founders of the new bodywork approaches include Lowen, Alexander, Feldenkrais, Rolf, and Aston, all based on the Reichian notion that emotional stress manifests as blocks in the muscle structure. The Laban-Bardini school of movement therapy pays special attention to the body moving through space and interacting with its environment. Ill health arises from a lack of synchrony and integration, and healing is induced by a process of interaction in which the rhythms of therapist and patient continually synchronize. Balance can also be approached through metabolism. Nutritional therapy, herbal medicine, and drugs are variations of one approach, and the holistic therapist will always use the mildest remedy, beginning with a change of diet, moving to herbs, using synthetic drugs only in emergencies. Clinical ecology is concerned with the impact of foods and chemicals on health and mental state. Common foods and harmless-seeming chemical products can cause headaches, depressions, and muscle pains. Herbal medicine has been almost forgotten with the rise of the biomedical model, though natural, unrefined plant material seems the best oral medication. Purifying and refining reduces the therapeutic effect, and herbal mixtures, tried out empirically for thousands of years, have inbuilt moderating effects that prevent resistant strains and side effects. Relaxation, meditation, and the Simonton approach. The last group of therapeutic techniques approaches psychosomatic balance through the mind. Current attitudes toward relaxation are naive. Watching television, reading, or having a few drinks do not reduce stress. Deep relaxation is a psychophysiological process requiring diligent practice, with correct breathing among its vital elements. Meditation, developed especially in the Far East, produces a response opposite to stress and will probably have important clinical applications. Autogenic training, developed by Johannes Schultz in the 1930s, is a form of self-hypnosis combined with exercises to integrate mental and physical functions and induce deep relaxation. In advanced stages, mental imagery and visualization play a central role, as in traditional meditation. Biofeedback helps a person achieve voluntary control over normally unconscious bodily functions by monitoring, amplifying, and displaying them. A wide range of autonomic functions, heart rate, body temperature, muscle tension, blood pressure, brainwave activity, can be brought under conscious control. The term voluntary control is inappropriate. What is required is not control, but, on the contrary, a meditative state of deep relaxation in which all control is relinquished, opening channels of communication between the conscious and unconscious mind. Biofeedback facilitates the shift of responsibility from therapist to patient, dramatically reducing helplessness and encouraging the positive attitude so important in healing, but should not be used in a reductionist way. Stress involves various patterns of psychosomatic functions, and biofeedback must be supplemented by more general methods of relaxation. The Simonton approach to cancer I consider a holistic therapy par excellence. Cancer is an illness characteristic of our age, illustrating many of the points of this chapter. The imbalance and fragmentation that pervade our culture play an important role in its development and prevent researchers from understanding or treating it successfully. The popular image of cancer, a strong, powerful invader striking from outside, does not correspond to the findings of current research. Cancer cells are not strong and powerful but weak and confused. They do not invade, attack, or destroy, but simply overproduce. A cancer begins with a cell containing incorrect genetic information. The communication and self-organization of malignant cells are impaired, so they grow larger and reproduce recklessly. In a healthy organism, the immune system recognizes abnormal cells and destroys them. But if the immune system is not strong enough, the mass of faulty cells continues to grow. Cancer, then, is not an attack from without, but a breakdown within. The crucial question is what inhibits a person's immune system at a particular time. The answer can be found only by considering the mental and emotional aspects of health. The emerging picture is consistent with the general model. Prolonged stress threatens some role or relationship central to the person's identity, generating feelings of despair and hopelessness, and suppressing the immune system, while hormonal imbalances increase the production of abnormal cells. Optimal conditions for cancer growth. Lucian's study of more than 500 cancer patients identified a characteristic life history: feelings of isolation and despair in youth, a strong relationship or role in early adulthood that becomes the center of life, its loss, resulting in despair, and internalizing the despair. The Simonton therapy affirms that the sequence of events leading to illness can be reversed. The first step is making patients aware of the wider context of their illness, identifying the major stresses 6 to 18 months prior to diagnosis, and discussing the patient's participation in the onset of their disease, not to evoke guilt, but to create the basis for reversing the cycle. At the same time, patients' belief in the effectiveness of treatment and the potency of the body's defenses is strengthened. The patient's response to treatment depends more on attitude than on the severity of the disease, and feelings of hope are translated into biological processes that restore balance and revitalize the immune system. The principal technique is relaxation and mental imagery, during which the cancer and the action of the immune system are pictured in the patient's own symbolic imagery. But visualization and physical therapy alone are not sufficient. The physical disease is a manifestation of underlying psychosomatic processes, and as long as these are not solved, the patient will not get well, even if the cancer temporarily disappears. Psychological counseling and psychotherapy are essential, dealing with emotional problems within the larger patterns of the patient's lives, including social, cultural, philosophical, and spiritual aspects. Dealing with death is an integral part of the therapy. Patients are made aware of the possibility that they may decide it is time to move toward death, and are assured that they have the right to make such a decision. The family often must give the patient permission to die, and whether or not one recovers from cancer, one can succeed in improving the quality of one's living or of one's dying. The confrontation with death touches the fundamental existential problem characteristic of the human condition, and the Simontons do not avoid any of these issues, which is why their approach is of exemplary value for healthcare as a whole. Shamanism. The belief that illness is disharmony with the cosmic order and healing the restoration of balance. A psychosomatic approach working with the collective unconscious. Hippocratic medicine. Health as a state of balance. The importance of the environment, the interdependence of mind and body, and nature's inherent healing power. The physician as attendant from therapeuin to attend. Qi and yin/yang. The dynamic balance of the organism as microcosm of the universe, correlative thinking, the flow of qi along the meridians, illness as disharmony. Dynamic balance, health as an ongoing process, a flexible pattern of fluctuations, 3 interdependent levels: individual, social, and ecological. Stress, imbalance in response to environmental influences, the fight-or-flight response, prolonged stress suppressing the immune system, illness as problem solver. Psychosomatic self-healing, the interdependence of mind and body at all stages of illness. The placebo effect as proof of the healing power of positive expectations. Patient participation, the recognition that we have participated in our illness and therefore can participate in healing. Partial and relative responsibility, not guilt. The Simonton approach, cancer as a breakdown within, not an attack from without. The reversal of the psychosomatic cycle through awareness, positive attitude, imagery, and the confrontation with death. Quote, "The relevance of environmental forces to the problems of human biology, medicine, and sociology has never been formulated with greater breadth and sharper vision than it was at the dawn of scientific history." René Dubos, as quoted by Capra, quote, "Whatever its precipitating cause and its manifestations, almost every disease involves both the body and the mind, and these two aspects are so interrelated that they cannot be separated one from the other." René Dubos, as quoted by Capra, quote, "Cancer management today is in a state of confusion. It looks almost like the disease itself, fragmented and confused." Carl Simonton, as quoted by Capra. 11. Journeys beyond space and time. Jung and the system's view of the psyche. In the system's view of health, every illness is in essence a mental phenomenon, and the process of getting sick is reversed most effectively through an approach that integrates both physical and psychological therapies. The conceptual framework underlying such an approach will include not only the new system's biology, but also a new system psychology, a science of human experience and behavior that perceives the human organism as a dynamic system of interdependent physiological and psychological patterns, embedded in larger systems of physical, social, and cultural dimensions. Carl Gustav Jung was perhaps the first to extend classical psychology into these new realms. In breaking with Freud, he abandoned the Newtonian models of psychoanalysis and developed concepts that are quite consistent with modern physics and systems theory. As he wrote in Ion, sooner or later, nuclear physics and the psychology of the unconscious will draw closer together. Psyche cannot be totally different from matter, for how otherwise could it move matter? And matter cannot be alien to psyche, for how else could matter produce psyche? Indeed, the differences between Freud and Jung parallel those between classical and modern physics, between the mechanistic and the holistic paradigm. Freud's theory of the mind was based on the concept of the organism as a complex biological machine, psychological processes following Newtonian mechanics. Jung, by contrast, attempted to understand the psyche in its totality and was concerned with its relations to the wider environment. He saw the psyche as a self-regulating dynamic system, characterized by fluctuations between opposite poles, and conceived the libido as a general psychic energy, a manifestation of the basic dynamics of life, much as Reich used bioenergy. The key difference between the two psychologists is in their views of the unconscious. For Freud, the unconscious was predominantly personal, containing elements that had been forgotten or repressed. For Jung, it was the very source of consciousness, and he distinguished a personal unconscious from a collective unconscious that represents a deeper stratum common to all humankind, a link between the individual and the entire cosmos, consistent with the system's view of mind. Jung described the collective unconscious in terms of archetypes, collectively present dynamic patterns, forms without content, representing merely the possibility of a certain type of perception and action, embedded in a web of relationships in which each archetype ultimately involves all the others, a concept surprisingly similar to the patterns of subatomic physics. Jung considered spirituality an integral part of the human psyche and saw the rational approach as merely one of several approaches to reality, identifying four functions of the psyche: sensation, thinking, feeling, and intuition. He expanded Freud's deterministic approach by postulating synchronicity, acausal connections between symbolic images in the inner world and events in the outer reality, a specific example of a more general acausal orderedness in mind and matter, now supported by the distinction between local and non-local connections in physics, where patterns of matter and patterns of mind are increasingly recognized as reflections of one another. Jung saw the mind as a self-organizing system, and neurosis as a process by which the system tries to overcome obstructions to functioning as an integrated whole. The role of the therapist is to support this process of individuation, integrating the conscious and unconscious aspects of the psyche, involving encounters with the archetypes of the collective unconscious, and culminating in the experience of the self. Psychotherapy, for Jung, flowed from a personal encounter involving the entire being of both therapist and patient, the product of mutual influence, in which the whole being of the doctor as well as that of his patient plays its part, requiring the therapist to observe his own dreams and study himself as carefully as he studies the patient. with the recognition of an increasing consistency between Jungian psychology and modern science. His ideas about the unconscious, the dynamics of mental phenomena, the nature of mental illness, and the process of psychotherapy are likely to have a strong influence on the future of psychology. Humanistic and transpersonal psychology. Around the middle of the 20th century, clinical psychologists developed theoretical models of the human psyche that differed markedly from both the Freudian and behaviorist models. Abraham Maslow, spearheading the school of humanistic psychology, rejected Freud's view of humanity as dominated by lower instincts and criticized behaviorism for its reliance on animal experiments. Freud supplied to us the sick half of psychology, he wrote. We must now fill it out with the healthy half. Maslow proposed a third force, humanistic psychology, focusing on human experience and asserting that feelings, desires, and hopes were as important as external influences. He concentrated on healthy individuals and positive aspects of behavior: happiness, satisfaction, peace of mind, joy, ecstasy, and studied peak experiences, transcendental moments he considered important stages in the process of self-actualization. In psychotherapy, this orientation encouraged a shift from patients to clients, and from a therapist as dominant authority to a human encounter between equals, as in Carl Rogers' client-centered psychotherapy. The human potential movement, centered at East Salem in California, developed a variety of nonverbal and physical techniques, sensory awareness, encounter, sensitivity training, that proliferated during the 1960s. Socially oriented psychologists, such as Harry Stack Sullivan and Karen Horney, emphasize the importance of interpersonal relations and cultural factors in mental illness, leading to family therapy, based on the assumption that the mental disorders of the identified patient reflect an illness of the entire family system, and group therapy, incorporating the new techniques of nonverbal communication and emotional release. By the mid-1960s, a new movement developed within the humanistic orientation, specifically concerned with the spiritual, transcendental, or mystical aspects of self-actualization. Transpersonal psychology, a term coined by Maslow and Stanislav Grof, concerned with the recognition, understanding, and realization of non-ordinary, mystical states of consciousness, and with the barriers to such realizations. Its concerns are close to those of spiritual traditions, bridging psychology and the spiritual quest, a radical departure from the Western schools that regarded religion as superstition or pathology, the notable exception being Jung. The new psychology emerging from these movements is consistent with the system's view of life and in harmony with spiritual traditions. As in the new system's biology, the focus shifts from psychological structures to the underlying processes. The psyche is a dynamic system, the dynamics involving a flow of energy that reflects an intrinsic intelligence, the equivalent of the system's concept of mentation, enabling the psyche to heal itself. The psychological situation of an individual cannot be separated from the social and cultural environment, and mental distress often originates in the breakdown of social relations, leading to the shift from individual to group and family therapies. An exciting development is the adaptation of the bootstrap approach to psychology. None of the existing schools is wrong. Freudian, Jungian, Reichian, Rogerian, and others. Each focuses on a part of the spectrum of consciousness, and psychologists may need a network of interlocking models, using different languages for different aspects and levels of reality, as we use different maps for different parts of the world. The spectrum of consciousness. One of the most comprehensive systems to integrate different psychological schools is the spectrum psychology proposed by Ken Wilber, which unifies numerous approaches, both Western and Eastern, into a spectrum of models reflecting the spectrum of human consciousness. Each level is characterized by a different sense of identity, ranging from the supreme identity of cosmic consciousness to the drastically narrowed identity of the ego. Wilber distinguishes four major levels. The ego level, where one identifies with a mental self-image rather than the total organism. The biosocial level, where social environment and cultural patterns map onto the organism and affect perception and behavior. The existential level, characterized by a sense of identity involving the entire mind/body system as an integrated whole. but still marked by the dualism of subject versus object and life versus death, and the transpersonal level, involving an expansion of consciousness beyond the conventional boundaries of the organism, a mode of consciousness in which the individual feels connected to the cosmos as a whole, approaching the direct, mystical experience of reality. At the end of the spectrum, the transpersonal bands merge into the level of mind, cosmic consciousness, where one identifies with the entire universe, the true mystical state, in which all boundaries and dualisms are transcended and all individuality dissolves into universal, undifferentiated oneness. Another map of consciousness, fully consistent with Wilbur's spectrum, has been developed through clinical experience by Stanislav Grof, who conducted some 3,000 psychedelic sessions using LSD as a catalyst. Grof's cartography of the unconscious encompasses three major domains: the psychodynamic, involving memories of emotionally relevant events from the individual's life history, organized in COEX systems, systems of condensed experience; the perinatal, involving the reliving of the actual birth process, with its four matrices corresponding to the stages of delivery, the serene bliss of the womb; the claustrophobic no exit of the first stage, the struggle through the birth canal; and the sudden relief of the first breath, closely related to the experience of death, so that Grof often refers to the entire phenomenon as the death rebirth experience; and the transpersonal, involving experiences that go beyond individual boundaries, providing deep insights into the spiritual dimension of consciousness, and often involving paranormal or psychic phenomena that are notoriously difficult to handle within the framework of rational thinking and scientific analysis. A true science of consciousness, I believe, need not be restricted to measurement and quantitative analysis. Any approach to knowledge is scientific if it satisfies two conditions. All knowledge must be based on systematic observation, and it must be expressed in terms of self-consistent but limited and approximate models. The patterns of experience constituting the data of a science of consciousness cannot be quantified or analyzed into fundamental elements, but the conceptual models interconnecting the data must be logically consistent. Wilbur's and Grof's maps are excellent examples of this new kind of scientific approach, a science that will quantify when appropriate, but will also be able to deal with qualities and values based on human experience. Mental illness and the spectrum of psychotherapy. The new bootstrap approach to psychology includes a conception of mental illness fully consistent with the general views of health and illness. Mental illness is a multidimensional phenomenon involving interdependent physical, psychological, and social aspects. The most serious disorders, the psychoses, cannot be understood without taking the biosocial, existential, and transpersonal domains into account. Failure to evaluate and integrate experience of reality seems central to serious mental illness. Many people diagnosed as psychotics are not judged on their behavior, but on the content of their experiences of a transpersonal nature, well known to mystics and occurring frequently in deep meditation, but in sharp contradiction to the classical Western worldview. The new definition of normal and pathological is not based on the content of experiences, but on the way they are handled and the degree to which a person can integrate them into life. Conventional psychiatric treatment, suppressing symptoms with psychoactive drugs, interferes with the organism's attempt to heal itself. Research into the families of schizophrenics has shown that the person diagnosed as psychotic is almost always part of a network of extremely disturbed patterns of communication within the family. The double bind identified by Gregory Bateson, a situation in which the person can't win no matter what he does, typically through contradictory verbal and nonverbal messages from parents. R.D. Lang has argued that the strategy of the so-called schizophrenic is an appropriate response to severe social stress, a desperate effort to maintain integrity in the face of paradoxical pressures, and that the normal, alienated condition of our culture is itself a form of madness. The Cartesian worldview is not merely the principal frame of reference, but is regarded as the only accurate description of reality. Yet to be limited to the Cartesian mode of perception alone is also madness. The madness of our dominant culture, characterized by ego-centered, competitive, goal-oriented lives, a sense of meaninglessness that no amount of external success can dispel. Genuine mental health involves a balanced interplay of the Cartesian and the transpersonal modes of experience, a way of life in which identification with the ego is playful and tentative, and concern with material possessions is pragmatic rather than obsessive. As Lang put it, mystics and schizophrenics find themselves in the same ocean, but the mystics swim whereas the schizophrenics drown. The multidimensional view of mental illness implies a corresponding multileveled approach to psychotherapy. At the ego or psychodynamic level, Freudian theory is the ideal framework for interpreting psychosexual dynamics and autobiographical phenomena, but it is limited to that domain and proves inadequate when deeper existential and transpersonal experiences emerge. The social context is addressed by approaches operating at the biosocial level, transactional analysis, family therapy, and forms of group therapy with political orientations. At the existential level, therapies such as Gestalt therapy, Reichian therapy, and bodywork combine psychological and physical techniques to integrate mind and body, often leading to profound experiences of birth and death interpreted through Groff's perinatal matrices. At the transpersonal level, the aim is to help clients integrate their transpersonal experiences with ordinary consciousness in a process of inner growth and spiritual development, using models from Jung's analytical psychology, Maslow's psychology of being, and Assagioli psychosynthesis. The idea that the organism has an inherent tendency to heal itself is as central to psychotherapy as to any other therapy. The new experiential therapies, Gestalt, psychedelic, primal, and the breathing techniques developed by Groff emphasize nonverbal expression, direct experience, and a combination of psychological and physical techniques, encouraging the client to suspend conceptual frameworks and trust the organism's own healing journey. The crucial resonance between therapist and client, the authentic meeting between human beings, is the catalyst that initiates the process. The ultimate obstacle for experiential therapies is no longer emotional or physical, but cognitive. Therapists must be familiar with the new paradigm emerging from modern physics, systems biology, and transpersonal psychology, so that they can offer their clients not only powerful stimulations of experience, but also the corresponding cognitive expansion. The collective unconscious, Jung's deeper stratum of the psyche, common to all humankind, archetypes as forms without content, embedded in a web of relationships. Synchronicity, a causal connections between symbolic images in the inner world and events in the outer reality, supported by the distinction between local and non-local connections in physics. Humanistic psychology, Maslow's third force, focusing on healthy individuals, positive experience, and self-actualization. Transpersonal psychology, the extension of humanistic psychology into the spiritual and mystical dimensions of self-actualization. The spectrum of consciousness, Wilber's four levels, ego, biosocial, existential, transpersonal, culminating in the level of mind. Perinatal matrices, Groff's four stages of the birth process, which also represent the death-rebirth experience. The double bind, Bateson's concept of the contradictory communication patterns in families of schizophrenics. Experiential therapy, the new therapies that mobilize blocked energy and transform symptoms into experiences, emphasizing the therapeutic encounter as an authentic meeting between human beings. Quote, sooner or later, nuclear physics and the psychology of the unconscious will draw closer together. Psyche cannot be totally different from matter, for how otherwise could it move matter? And matter cannot be alien to psyche, for how else could matter produce psyche? Carl Gustav Jung, as quoted by Capra, quote, mystics and schizophrenics find themselves in the same ocean, but the mystics swim whereas the schizophrenics drown. R.D. Lang, as quoted by Capra, quote, the really decisive moments in psychotherapy, as every patient or therapist who has ever experienced them knows, are unpredictable, unique, unforgettable, always unrepeatable, and often indescribable. R.D. Lang, as quoted by Capra. 12. The passage to the solar age. The system's view of economics. The system's view of life is an appropriate basis not only for the behavioral and life sciences, but also for the social sciences, and especially for economics. The application of systems concepts is particularly urgent because virtually all our current economic problems are systemic problems that can no longer be understood via Cartesian science. Conventional economists generally lack an ecological perspective, dissociating the economy from the ecological fabric in which it is embedded and describing it in terms of simplistic, highly unrealistic theoretical models. Most of their basic concepts, narrowly defined and used without ecological context, are no longer appropriate for mapping economic activities in a fundamentally interdependent world. The situation is aggravated by the avoidance of the value system on which their models are based, tacitly accepting the highly imbalanced set of values that dominates our culture. Overemphasis on hard technology, wasteful consumption, rapid exploitation of natural resources, all motivated by the obsession with undifferentiated growth that is causing ecological disasters, corporate crime, social disintegration, and the ever-increasing likelihood of nuclear war. The system's approach to economics will give economists the urgently needed ecological perspective. The economy is a living system composed of human beings and social organizations in continual interaction with one another and with the surrounding ecosystems on which our lives depend. Ecosystems are self-organizing and self-regulating systems linked through a complex web of interdependencies involving the exchange of matter and energy in continual cycles. The recognition of the nonlinear nature of all systems dynamics is the very essence of ecological awareness, what Bateson called systemic wisdom, characteristic of traditional, non-literate cultures but sadly neglected in our over-rational and mechanized society. Systemic wisdom is based on a profound respect for the wisdom of nature. The organizing principles of ecosystems, which have co-evolved over billions of years, must be considered superior to those of human technologies based on short-term linear projections. The non-linear interconnectedness of living systems suggests two important rules. First, there's an optimal size for every structure or institution, and maximizing any single variable, profit, efficiency, GNP, will inevitably destroy the larger system. Second, the more an economy is based on the continual recycling of its natural resources, the more it is in harmony with the surrounding environment. The global interconnectedness of our problems and the virtue of small-scale, decentralized enterprises represent a pair of complementary opposites, expressed in the slogan, "Think globally, act locally." The dynamics of an economy, like that of any living system, is dominated by fluctuations. J. Forrester has identified three distinct cycles: a 5 to 7 year cycle reflecting the interaction between employment and inventories, an 18-year cycle related to the investment process, and a 50-year cycle reflecting the evolution of technologies. An economy, like any living system, will be healthy if it is in a state of dynamic balance, characterized by continual fluctuations. To achieve and maintain this balance, we must preserve ecological flexibility and create the social flexibility needed to adapt to environmental changes. As Bateson said, social flexibility is a resource as precious as oil. The task of mapping the economy will require a multidisciplinary approach, involving insights from ecology, sociology, political science, anthropology, psychology, and other disciplines. The end of economics as the predominant basis of national policy. Economics will remain appropriate for accounting and microanalysis, but its methods are no longer adequate for macroeconomic processes. An important new role will be estimating the social and environmental costs of economic activities, internalizing them within the accounts of private and public enterprises. In the new conceptual framework, energy and entropy will be important variables for measuring economic activities, and the concepts of efficiency, productivity, and profit will be redefined within a broad ecological context. Scale, decentralization, and the restoration of balance. Our economy, social institutions, and natural environment are seriously out of balance. The obsession with growth has led us to maximize too many variables: GNP, profits, the size of cities and institutions, and the result has been a general loss of flexibility. As in individual organisms, this imbalance can be described in terms of stress, and the various aspects of our crisis can be seen as multiple symptoms of social and ecological stress. To restore a healthy balance, we must return overstrained variables to manageable levels. Decentralization of populations and industrial activities, dismantling of large corporations, redistribution of wealth, and the creation of flexible, resource-conserving technologies. The restoration of balance and flexibility will require a profound change of values, from self-assertion and competition to cooperation and social justice, from expansion to conservation, from material acquisition to inner growth. The question of scale will play a central role, the criterion being comparison to human dimensions. What is too large, fast, or crowded in comparison to human dimensions is too big. Urbanization will be a crucial aspect of the return to a more human scale, not enforced but allowed to happen by creating the economic incentives and technologies that permit people who wish to make the transition from urban to rural life. The nation-state is no longer workable as an effective unit of governance. Political decentralization and regional development have become urgent needs, and the recognition that we cannot manage the planet but must integrate ourselves harmoniously into its multiple self-organizing systems calls for a new planetary ethic and new forms of political organization. The return to a more human scale will require the development of ingenious new forms of technology, soft technologies that are small-scale, decentralized, responsive to local conditions, designed to increase self-sufficiency, incorporating the principles observed in natural ecosystems and reflecting systemic wisdom. Solar energy collectors, wind generators, organic farming, regional and local food production, and recycling of waste products are examples. As Schumacher observed, wisdom demands a new orientation of science and technology towards the organic, the gentle, the nonviolent, the elegant, and beautiful. The shift from hard to soft technologies is most urgently needed in energy production. The only way out of the energy crisis is to follow a soft energy path, with three main components: conservation of energy by more efficient use, intelligent use of non-renewable sources as bridging fuels during the transition, and rapid development of soft technologies for energy production from renewable sources. Conservation turns out to be our best short-term energy source, outstripping all conventional fuels combined. During 1973 to 78, 95% of all new energy supplies in Europe came from more efficient use, and the United States obtained 72% of its new energy from conservation. The greatest savings can be achieved by insulating buildings. It is now technically possible and highly cost-effective to make buildings so heat-tight they need virtually no space heating, and by cogeneration, the combined production of useful heat and electricity. The solar transition. In the long run, we need an energy source that is renewable, economically efficient, and environmentally benign. Solar energy is the only kind that satisfies all these criteria. The sun has been the planet's main energy source for billions of years, and virtually all the energy we use, except for nuclear power, represents some form of stored solar energy. Solar energy, in the narrower sense, energy from inexhaustible or renewable sources, is available in forms as varied as the planet itself, as a solid fuel, wood in forested areas, as liquid or gaseous fuel, alcohol or methane from plant products, in agricultural areas, as hydroelectric power in mountainous regions, as wind-generated electricity in windy places, as electricity from photovoltaic cells in sunny areas, and as direct heat almost everywhere. The solar transition does not require any major technological innovations. It simply involves the judicious integration of long-known agricultural and technological processes into our modern society. Solar heating is already competitive and represents a vibrant, rapidly expanding industry. Photovoltaic cells, which convert sunlight directly into electricity, are going through the same stages as the semiconductor industry did 2 decades ago. A substantial federal investment would bring their costs down to competitive levels easily. The production of methane from biomass, garbage, sewage, manure, agricultural residues, comes closest to the principles observed in natural ecosystems, involving the cooperation of other organisms in recycling major pollutants. The main obstacles to the solar transition are not technical, but political. The shift from non-renewable to renewable resources will force the oil companies to give up their dominant roles, and the transition will be possible only if we are able, as a society, to put long-term social returns before short-term private gains. The rising culture and the transformation of values. The transition to the solar age is really underway now, not merely in terms of new technologies, but as a profound transformation of our entire society and culture. The shift from a mechanistic to the ecological paradigm is happening right now in our sciences, in our individual and collective attitudes and values, and in our patterns of social organization. The new paradigm is better understood by individuals and small communities than by large institutions locked into Cartesian thinking. The restructuring of information and education is necessary and has already been taken up by citizen movements, public interest groups, and alternative networks. Journalists will need to develop a new professional ethic based on social and ecological awareness. The restructuring of knowledge will involve a profound transformation of our educational system, already occurring in thousands of spontaneous adult education efforts undertaken by the social movements of the 1960s and 1970s. The decade of the 1970s saw a proliferation of citizen movements formed around social and environmental issues, concerned with corporate accountability and the influence of large corporations on government policies. The ecology movement maintains information centers and publishes on environmental protection, organic farming, and recycling. Citizen and consumer movements are the sources of emerging countereconomies, informal, dual, convivial economies based on decentralized, cooperative, and ecologically harmonious lifestyles, involving the bartering of skills and home-produced goods and services. The new emphasis on dual economies is based on the realization that the informal, cooperative, non-monetized sectors are predominant in the world's economies, and the institutionalized, monetized sectors grew out of them and rest upon them. More and more people are dropping out of the monetized economy, adopting communal, reciprocal, and cooperative ways of living, working only a few hours a week to earn a minimum of cash. Worker participation and self-management movements are active in Canada and several European countries, with the first successful model achieved in Yugoslavia. A significant shift of values has been observed in the general population, a shift from material consumption to voluntary simplicity, from economic and technological growth to inner growth and development. The Stanford Research Institute estimated in 1976 that 4 to 5 million adult Americans had drastically reduced their incomes and withdrawn from the consumer economy in favor of voluntary simplicity, with another 8 to 10 million living according to some of its tenets. Deep ecology and the feminist spirit. The new vision of reality is an ecological vision in a sense that goes far beyond immediate concerns with environmental protection. Philosophers and scientists have begun to distinguish between deep ecology and shallow environmentalism. Shallow environmentalism is concerned with more efficient control and management of the natural environment for the benefit of man. Deep ecology recognizes that ecological balance will require profound changes in our perception of the role of human beings in the planetary ecosystem, a new philosophical and religious basis. Deep ecology is supported by the new systems approach, but is rooted in an intuitive awareness of the oneness of all life, the interdependence of its multiple manifestations, and its cycles of change and transformation. Ecological awareness is truly spiritual, the idea of the individual being linked to the cosmos expressed in the Latin root of the word religion, religare, to bind strongly, and in the Sanskrit yoga, meaning union. The deep ecology movement is reviving an awareness that is part of our cultural heritage, from Taoism and Heraclitus to St. Francis, Spinoza, Heidegger, and Native American culture. What is new is the extension of the ecological vision to the planetary level, supported by the images of spaceship Earth and the whole Earth. The spiritual essence of the ecological vision finds its ideal expression in the feminist spirituality advocated by the women's movement. The natural kinship between feminism and ecology rooted in the age-old identification of woman and nature. Feminist spirituality is based on awareness of the oneness of all living forms and of their cyclical rhythms of birth and death, reflecting an attitude toward life that is profoundly ecological. The image of the goddess represents a solution to the metaphysical problem of the one and the many in terms of union and mutual embodiment, with the one manifest in the many and the many dwelling within the one, characterized by harmony, warmth, and affection, reflecting the mother's unconditional love. The feminist movement will continue to assert itself as one of the strongest cultural currents of our time. Its ultimate aim a thorough redefinition of human nature. The struggles of ethnic liberation movements, homosexuals, the old, the physically handicapped, all questioning authority and rigidly assigned social roles, and the resistance of third-world countries to the industrialized world's attempts to explore its problems are all part of the same transformation. The new alliances and coalitions that interlink hundreds of groups and networks are non-hierarchical, non-bureaucratic, and non-violent. As they continue to give substance to the new vision of reality, a critical mass of awareness will be reached that will allow them to coalesce into new political parties. The Democratic and Republican parties, the traditional right and left, and most of our academic institutions are part of the declining culture in the process of disintegration. The social movements of the 1960s and 1970s represent the rising culture, which is now ready for the passage to the solar age. The declining culture refuses to change, clinging ever more rigidly to its outdated ideas. But it will inevitably go on to decline and disintegrate while the rising culture will continue to rise and eventually assume its leading role. As the turning point approaches, the realization that evolutionary changes of this magnitude cannot be prevented by short-term political activities provides our strongest hope for the future. Systemic wisdom. The recognition of the nonlinear nature of all systems dynamics, the essence of ecological awareness, characteristic of traditional cultures, neglected in our mechanized society. The soft energy path, conservation, bridging fuels, and rapid development of renewable sources, the most efficient, cheapest, and most environmentally benign energy policy. The solar transition, the shift from non-renewable to renewable energy sources, not requiring major technological innovations, only the political will to put long-term social returns before short-term private gains. The entropy state, Henderson's term for the stage at which the costs of bureaucratic coordination exceed society's productive capabilities, the whole system winding down of its own weight. Deep ecology, the recognition that ecological balance requires profound changes in our perception of the role of human beings in the planetary ecosystem. A new philosophical and religious basis. Feminist spirituality, the spiritual essence of the ecological vision, the oneness of all living forms, the cyclical rhythms of birth and death, the goddess as the image of union and mutual embodiment. The rising culture, the ecological, feminist, anti-nuclear, human potential, and holistic health movements, coalescing into new political parties, ready for the passage to the solar age. The turning point, the realization that evolutionary changes of this magnitude cannot be prevented by short-term political activities, our strongest hope for the future. Quote, social flexibility is a resource as precious as oil. Gregory Bateson, as quoted by Capra. Quote, wisdom demands a new orientation of science and technology towards the organic, the gentle, the nonviolent, the elegant and beautiful. F. Schumacher, as quoted by Capra. Quote, the needs of the planet are the needs of the person. The rights of the person are the rights of the planet. Theodore Roszak, as quoted by Capra. Conclusion. The turning point is a diagnosis of our civilization in the register of a physicist who has lived through one conceptual revolution and sees the rest of culture still imprisoned in the old one. The book's central claim is that the crisis of our time is a crisis of perception, and that the perception is the Cartesian-Newtonian worldview, the universe as a machine, the mind split from matter, nature as a resource to be dominated. Assemble the facets, nuclear weapons, toxic waste, the diseases of civilization, the impasse of economics, the arrogance of technology, and a single pattern appears, a paradigm that has outlived its usefulness, applied to a reality that can no longer be understood in its terms. The physicist's own revolution is the model. Just as quantum theory and relativity shattered the world machine and revealed the universe as an interconnected, dynamic web in which the observer is essential, so the other sciences must transcend the mechanistic and reductionist approach and develop holistic and ecological views. What the book costs the reader is considerable. It asks us to abandon the image of the world as a machine composed of parts, the image of the body as a clockwork, the image of the mind as a separate substance, the image of the economy as a self-balancing mechanism, and the image of nature as a resource to be exploited. It asks us to accept that the individual is not invulnerable to propaganda, that education can prepare the victim as well as the citizen, that the Cartesian mode of perception alone is itself a form of madness, and that the environment is not mindless but mindful like ourselves. In exchange, it offers a vision of reality that is scientific and spiritual at the same time. The system's view of life, health as dynamic balance, the integration of Western psychotherapy with transpersonal psychology, and the passage to the solar age. The book is scrupulous about its own limits. Its claims about the new physics are qualified by the physicist's own caution. All our concepts and theories are limited and approximate. Its maps of consciousness are metaphors. Its prognoses are hedged. The validity of the vision does not depend on any single theory being right, but on the pattern of the whole. As the author says, none of its elements is really original, but the interconnections and interdependencies between the various parts represent the essence of the contribution. Its afterlife has been that of a book which defined the terms of a cultural conversation. The paradigm shift, the system's view, the rising culture, the solar transition, deep ecology, the marriage of physics and mysticism. What endures is not a program. The author proposes none, but a diagnostic and a hope. The realization that evolutionary changes of this magnitude cannot be prevented by short-term political activities, and that the rising culture will eventually assume its leading role. Key persons discussed. Fritjof Capra, the author, physicist, author of the Tao of Physics, here extending the physics and mysticism thesis to all of science and culture. René Descartes, the founder of the paradigm, the analytic method, the mind-matter division, the world as a machine. Also, ironically, the physician who prescribed relaxation for the Princess Elizabeth. Isaac Newton, the completer of the world machine, absolute space and time, material particles, the force of gravity, the last of the magicians. Albert Einstein, the initiator of the new physics, relativity, and the quantum, the searcher for harmony who could not go beyond Descartes. Niels Bohr/Werner Heisenberg, the founders of quantum theory, complementarity, probability, the observer's consciousness, the limits of concepts. Gregory Bateson, the anthropologist who defined mind as a systems phenomenon, coined the double bind, and called social flexibility a resource as precious as oil. Carl Gustav Jung, the psychologist who abandoned Newtonian models for the collective unconscious, archetypes, synchronicity, and individuation. Arnold Toynbee/Pitirim Sorokin, the historians of civilizations, challenge and response, and the sensate/ideational/idealistic fluctuation of value systems. E.F. Schumacher, the economist of small is beautiful and the technology with a human face. Theodore Roszak, the historian of the counterculture of person/planet. Abraham Maslow/Stanislav Grof/Ken Wilber, the humanistic and transpersonal psychologists, self-actualization, the cartography of the unconscious, the spectrum of consciousness. R. Hillang, the psychiatrist of the double bind and the normal madness. Mystics and schizophrenics find themselves in the same ocean, but the mystics swim. Carl Simonton/Stephanie Matthews Simonton, the holistic therapist of cancer, imagery, attitude, and the confrontation with death. Key works discussed. The Tao of Physics, Capra, 1975, the author's earlier argument that modern physics and Eastern mysticism converge, the starting point of the present thesis. A study of history, Toynbee the model of challenge and response, and the rise and fall of civilizations, source of the rising culture. Social and cultural dynamics, Sorokin, 1937 to 41, the fluctuation of the sensate, ideational, and idealistic value systems, in which the current paradigm shift is the twilight of the sensate era. The I Ching, Book of Changes, the ancient Chinese wisdom of cyclical change and dynamic balance that frames the book's model of cultural dynamics. The Neurotic Personality of Our Time, Karen Horney, the feminist critique of Freud's female psychology. What is life? Erwin Schrödinger, the book that turned physicists toward biology and the gene as information. Ion, Jung, the prophecy of the convergence of nuclear physics and the psychology of the unconscious. Getting Well Again, Simonton, Matthew Simonton, Creighton, the holistic cancer therapy the author considers exemplary. Small is beautiful. Schumacher, the economics of scale and the technology with a human face. The entropy law and the economic process. George S. Garogan, the introduction of entropy into economic theory. The politics of the solar age. Hazel Henderson, the futurist economics of the solar transition. The implicate order/wholeness and the implicate order. David Bohm, the physics of unbroken wholeness and the enfolded order. Index of key concepts. Paradigm shift, the fundamental change in thoughts, perceptions, and values forming a particular vision of reality. The book's central concept, from the mechanical to the ecological paradigm. The Cartesian-Newtonian worldview, the universe as a perfect machine governed by exact mathematical laws, with the mind split from matter, reductionism as the method, and the domination of nature as the aim, the framework transcended by modern physics. The world machine, the dominant metaphor of the modern era, displacing the medieval organism. The 17th century clockwork extended to nature, living organisms, and society. Reductionism, the belief that complex phenomena can be understood by reducing them to their constituent parts. The method of Cartesian science, insufficient for the integrative functions of living systems. The new physics, quantum theory and relativity, probability waves, non-local connections, statistical causality, the observer's consciousness, the bootstrap philosophy, the universe as an interconnected, dynamic whole. The systems view, the world in terms of relationships and integration. Integrated wholes whose properties cannot be reduced to those of smaller units. Self-organizing, self-renewing, self-transcending systems. Self-organization, the principle by which living systems establish their own order, autonomy, feedback loops, dynamic stability, self-renewal, and self-transcendence. The basis of the system's view of life. The Gaia hypothesis, the planet as a single living, self-regulating organism. A scientific hypothesis and an ancient myth revived by Lovelock and Margulis. The biomedical model, the body as machine, disease as breakdown, the doctor as repairman, the conceptual foundation of modern medicine and the source of its crisis. Health as dynamic balance, the system's concept of health, flexibility, integration, the three levels of individual, social, and ecological health, stress as imbalance, illness as a message. Psychosomatic self-healing, the interdependence of mind and body at all stages of illness. The placebo effect, the patients will get well, the recognition of our participation in illness and healing. The collective unconscious, Jung's deeper stratum of the psyche, common to all humankind. Archetypes as forms without content, the felt connection of the individual to humanity and the cosmos. The spectrum of consciousness, Wilber's four levels, ego, biosocial, existential, transpersonal, culminating in the level of mind, the true mystical state. The double bind, Bateson's concept of the contradictory communication patterns in the families of schizophrenics. The impossible situation in which one can't win. Undifferentiated growth, the obsession of both capitalist and communist economies. Unlimited expansion in a finite environment, related to Jung values and Newtonian notions of infinite space. The soft energy path, conservation, bridging fuels and renewable sources, the efficient, cheap, and benign energy policy, culminating in the solar transition. Deep ecology. The recognition that ecological balance requires profound changes in our perception of our role in the planetary ecosystem. A new philosophical and religious basis. The rising culture. Toynbee's model applied. The ecological, feminist, anti-nuclear, human potential, and holistic health movements, which will flow together into a powerful force of social transformation. The turning point. The reversal and the fluctuation between yin and yang. The crisis as transformation. The movement toward the solar age and the new vision of reality. Reading comprehension questions. Recall. What are the three transitions that Capra identifies as coinciding in the current cultural transformation, and what is the turning point they jointly produce? Recall. What are the four sets of concepts that Freud's psychoanalysis shares with Newtonian mechanics, and what are the corresponding 4 points of view of psychoanalysis? Recall. What is the biomedical model, and what does the author identify as its most serious shortcoming? Relation. How does the new physics, probability, non-local connections, the observer, serve as the model for the paradigm shift the book advocates in the other sciences? Relation. Why does the author hold that the unit of survival is the organism in its environment rather than the species, and what follows for an organism that thinks only of its own survival? Mechanism. Trace how the book connects the Cartesian division between mind and matter to the diseases of civilization and to the exclusion of healing for medicine. Relation. How does the concept of health as dynamic balance integrate the 3 levels of individual, social, and ecological health, and what does stress represent in this view? Value assumption. What must be assumed about the value of scientific knowledge relative to intuitive wisdom for the book's claim that the yang-over-yin imbalance lies at the root of the crisis? What trade-off does the book never argue for? Ambiguity. Which sense of paradigm shift, descriptive how science actually changes, or prescriptive how it should change, is doing the work in the claim that the other sciences must follow physics, and what happens if we substitute the other sense? Wishful thinking / gray conclusion. Under what conditions would the rising culture fail to flow together into a powerful force? And what does the book leave out about the fragility of its prognosis? Where might a sympathetic reader accept the solar age transition because it is hopeful rather than because the evidence forces it?